Hey guys,
Hello.
how are you doing?
Good evening, doing well. How are you?
Pretty good, sir. Pretty good. I'm going to try something different today. I don't know if it succeeds or not, but we'll figure it out. What I have in mind is using an iPad to run the class, which is kind of scary thing to do, but I might give it a shot. But just for a few minutes. If it doesn't work out, we have this other option already. But there is a new feature set that has come into Zoom, which allows me to use exclusively use iPad and even share my screen. That is something I wanted to try. So maybe today is a good day. I don't know. We'll find out
I've
if it
used
works.
I've used my iPad for my video and my uh, watching the class before, so it
Right, right. That is okay. But what I'm doing is as a presenter, can I project my iPad screen to you and can you see it properly? Can you make sense out of it? And is it actually any more productive than regularly using a full-fledged desktop with a keyboard or a track or a pad like this? That's the question I have for myself. So this thing that I use is the extra device that I need to usually use, so I can write on the screen and all that. But I'm a nerd. As you probably know that. I don't need to tell you. But I like to use writing instruments of variety of different types, and so this is an evolution of technology where I can potentially start Zoom right here on, where is that Zoom thing on the iPad? Let me see if I can actually, let me project.
I
Zoom
know what you
start.
want to do. You want to be out by the beach in Hawaii
You
doing the class.
exactly, exactly. You read my mind. That's exactly what I want to do. And so what I'm doing is, how do you read my mind? I mean, that's amazing. So I just
Great
started.
minds think alike because I want to do the same thing.
I know. So
Pool
I have
deck,
a,
beautiful sunset, doing a class.
why not? Why not? Exactly. That is my goal. So what I'm going to give now right now is a shot at see if I can actually project my Zoom desktop through the iPad. So let's go. Let it go. Let it broadcast, and let's see what happens. So it should 3, 2, 1. There should be, yeah, it should be there. You should see my desktop coming up in the other window. There should be another Nilesh, and that Nilesh should be showing you some kind of a display on the iPad. Is that visible to you right here?
Yes, yes.
And is this legible? Can I write something here? And is it legible to you?
We cannot read the text, the bottom, but everything else is visible. Yep, that's better.
Okay, so yeah, this gives me the ability to like zoom at comfort. So I can go use my fingers to zoom and just circle around and maybe talk about this, focus on that. That is the better part of this experience for me at least. But I don't know if it actually works out for you. So we'll give this a shot. So let's get ready. So I think Rob and I discussed briefly, and he had something of interest that I think I would like you to bring it up, Rob. So if you can please mention what you had in mind, and I'll stop projecting
Okay.
and just focus on what you had in mind. So why don't you discuss that?
Okay, so before I share my screen, I just want to set the stage. A friend of mine who I help mentor, he's a young man, is working on a project for DevOps, developers and operations. And we would like to show it to you guys and get your feedback. Let us know. It culminates really what we've been talking about in the class and puts a UI, a visual aspect on top of what we've been.
Hey, Rob, I think we lost your sound. Rob, I think we lost him.
Yeah, no, okay, I'm back.
Yeah,
I
okay.
think I keep losing because I have the other machine. Let me go disconnect the other machine,
Okay.
and then I'll come right back.
Okay. So what Rob was talking about, he and his friend that he mentors has developed something interesting. So he wants to show it to us. I saw it briefly. I think it's kind of interesting in terms of how it does. Is that he has? I think I'll let him describe what he would like to say about what the project is, and so he'll show it to us. And so
Yeah, let me go ahead and share my screen.
Okay.
And
I hope it's not going to take long, like maybe a few minutes, and
nope.
that should do it. So,
Let me
yeah,
know if you can
there we
see
go.
my screen.
Yes.
Okay, so what we have here is on the right-hand side, we have the application. On the left-hand side, we actually have a system that is running, and the application, the server is actually running right here, and it's a Node.js server. So let me go in and look at, do a Docker PS and show that we have two different containers running. We have an Alpine node, which Alpine is a very small container, Linux container, running the actual data server, the server, and then we have a Mongo database entry point. So let me go ahead and log in. As you can see, it's called IcePanel. And what we have is we have engines, we have your projects, we have plugins. And so the plugins are what wrap the different containers that we allow other developers and other people to be able to add their containers and their applications specifically to this. So I will show you how each of these containers work, and except Docker. Docker is kind of the underlying plugin for allowing to manage Docker images. One of the cool things is we have our own IDE and development for those plugins in here. So if you come into Apache, you can see that we're using our model view controller state. So the plugin main TS, we're using TypeScript, is your model and controller. And so it's a very short amount of code to do this plugin. And then your view allows you to actually input your view. So this is the individual individual component here. So let me make sure that I change this IP address to my current IP address, which is on this machine, I'm using this 3.55. So actually what I'm going to do is I'm going to change this to just make it localhost. And then I'm gonna, and what's really interesting about this is I just made a change and I can install this Apache. Now that Apache is now updated over here automatically. I just did an install. So let's go ahead and start an engine over here on this machine. The way you do that is you generate your engine. We have a couple different helper functions in here for count and dates and things like that for expiration. But I'm gonna call this one Rob Demo 1 so it shows up. I'm going to generate the command. I cut and paste this command so I have a little copy over here. I'm going to bring it over here and I'm going to paste it. And so this is just the running of the slave machine, and you should see it come up over here. So that's the slave. That's a one-to-one relationship between your Docker slave, which is a proxy on a single machine. So you can have it one-to-one to any of your VMs in the cloud. So we would be able to, you would be able to start up your cloud, run that command, and it would start that proxy server on that cloud. Now, how do we use that? We come over here and we create a project. So I'm going to name that project Rob Demo 01, if I can type properly. And so now we have this demo. Now, how do we use this? So we have this selection tool up here. We can add a network, we can add an engine. Let's add that engine that we just created. So the engine is a container that contains other plugins. So we create a first engine, we double click on that, and we select the engine that we just created. Notice that we give an IP and a port that engine's running on. Now we have a couple of different things over here that allow us, so we have two Apaches, that's something that we'll have to fix, but the hardware, we have a volume. So we remember what Nilesh was teaching us about volumes. Well, we can actually create that volume here. And then I give it a volume name. I'm going to call it data. What's interesting about this is this actually creates a volume over here. So if we were to come over here and do a Docker volume ls, let me spell volume correctly, you'll see master data and master config. So these are two volumes that this is created and that our server is using. And then also, if we were to create a terminal session, so I want to create this Debian session because I want to demonstrate the terminal session. So we do terminal. And now if I come back over here and I do Docker PS, you'll see that we have now a Debian, and we have our slave, and we have our 2 servers. Now let's say I want to connect this data up. Now I can connect the data up. It's restarted the server. Now I have another plugin. It's called a tools plugin. So each of these plugins can actually have tools that you add to it. So we're going to add a terminal tool to this. And I'm going to go into that terminal. And I like using LL, so I'm going to alias that to ls-la, just so it's easier for you guys to see what we're doing. So notice that the data directory right here has been created. So if I go into CD data, notice that there's nothing here yet. Haven't really connected anything to that. So let's go ahead and change that. Let's go ahead and come over here to the Apache server. Now this is going to be interesting because I don't know which Apache server I'm running here. But let's just use web server and say OK. Now the Apache server, I can also have a terminal. Okay, so the terminal will allow me to have the Apache server, and I can actually view the site. Let me do 8080 on this and say save. And then I'm going to view this site. And it's still, oh, I haven't restarted it yet. I have to let it restart. Let me restart it. Okay. And view site, 8080. It works. Okay, so now we want to do is we want to save our data. We want to be able to control the data on that. So what we do is we'll connect the web server up to data, and it's downloading some packages and it's doing its work. Now it's connected. So I want to be able to change things on that. So let me go over here, add the files object to this, and notice that if I come back over here and I go to the terminal and now I look at data, notice that index.html is there. If I cat it, it's work index. So we just have a running web server within minutes. I actually could do it in seconds, but I'm talking, so it's minutes. So let's go back and let's take a look at the files. Let's change that file. So one easy way to do that is just to upload a new index.html file. So that was pretty much what it did. I came down here, I uploaded, I selected the index.html file, and it automatically opens it because that dialog automatically does that with this KDE. So now, notice it's changed. Now if I come over here, and now it works. And if I come back over to the web server and I look at the terminal, you can see the terminal output. If I come back over to terminal data, I can see that the index has changed. If I cat the index.html, it's changed. So within minutes, I now have a running jump box. Terminal could be your jump box, your data volume, and your web server. That's it. Any questions?
I think this is good. And questions are, of course, welcome.
Well, that was really cool, Rob. I'll tell you that. That's a real world kind of example. That's cool.
Yeah. Yeah, he
Thank you.
simplified, Rob has simplified a whole lot of what I call terminal work, and just bring up a particular thing that you would like to have as the project defines the concept of a project and an engine and a plugin, and you can construct your own place to drag and drop and put things together without having to go through the grunt. I think that's a good value.
Yeah. Hey, is that on GitHub, Rob?
It is not on GitHub. It is not a public product yet. We're still doing quite a bit of work on it. There's a lot of rough edges. So he's still programming a lot of this, but
Yeah.
he wanted to get feedback to ask, are we even in the ballpark of something useful for
Oh, come on, yeah.
and ops?
Yeah, don't sell yourself short. That's really good stuff.
Oh, thank you.
I mean, it's, the really fun thing about it is that it's, GUIs are great because they're helpful for learning and conceptualizing. maybe you can't get exactly the same control you get with, typing letters in through a terminal and a complex YAML files, whatever. But, a lot of what we do is repetitive, and sometimes it's fun to experiment with things quickly. So that's where I see this coming in.
Oh, good. Okay. Experimentation. Yeah.
Or I don't know. I mean, I'm not saying that you couldn't put it in production. Maybe, you could find a way to do like a testing pipeline with this or something like that.
Yeah, that would be good to do.
Yeah, integration with some kind of a CI/CD would be nice one to think of.
Yeah, so if you guys, that's where this developer tools comes in. If you guys could create a plugin to do whatever you want it to do, we're just providing the platform.
I see Minecraft's in there.
Yeah, that was one of the that's one of the ideas that we had was game servers are really popular. Back on and stuff like that. So really looking at taking 13, 14, 15-year-olds and they want to play game servers.
Right.
There's an easy way to manage that.
Right.
In the cloud.
There you go.
Rob, I missed the first part of that. Where are you developing this?
No, it is a young man that I help mentor in software development over in the UK. He's the developer. He just wanted me to get some feedback from real life developers and operations engineers that have real experience with these types of tools and wanted to know what you guys thought.
Yeah, cool.
Yeah, I think it's good. Good.
Okay.
Yeah, party parrot. Give him the party parrot.
The pony. Say
Party
that
parrot.
Oh, the party parrot. Yes. Okay. Okay. I'm gonna log off. Is there any other questions? Did you guys want to? If there wasn't, I'll go ahead and stop sharing, and then I'll hand it back over to Nilesh. Okay, great. Thank you very much. I appreciate the time.
Sweet deal. Now let me see if I can project. And if this iPad thing causes too much trouble, please tell me. I'll switch back to the old ways of doing things. And I am projecting, about to project now. And here we go. So my screen should be coming up in 3, 2, 1. There we go. And it should pop up. And what I'm doing here is focusing on our architectural diagrams. And I have a lot of them. And I think what I will do is I'll paste links to these things onto Slack chat as we go along. Or maybe if Travis, you have them, can you dump them in Slack if you have them handy? If not, I have them here and I'll dump them. But let me just focus on the ideas first. So in here, if you find them, there are lots of these pictures that you will find on the internet. And this is just a small subset collection that I seem to like some of them. So I have picked and chosen these guys for our discussion. But I will cover other things also. We are not limiting ourselves to just these. But I want to begin somewhere. So this is my beginning point. One of the things that I would like to begin with is to understand, by the way, these pictures, as you see, are almost all of them are Amazon pictures. Amazon Web Services are the leaders in this domain in cloud computing as such. So you may see that they have been doing this business for, I think, about close to 9 or so years. So they have the first mover advantage. They prepared their own architecture center. And then they created all these illustrations as to what does it take to build something out. And they first began with creating this picture, which is kind of sort of a representation of how Amazon Web Services thinks retail e-commerce websites should be constructed. Or in other words, how is Amazon.com constructed? So that's an illustration of what they think. This picture is an illustration of what they think a typical retail service should be functioned and designed and laid out. They have done this work actually in 3 parts. This piece of puzzle is the website front end part. There are 2 more pictures to go along with this. And those 2 are the marketing pieces and recommendations engine. And the third one being checkout. So the actual purchase access and the shopping cart and other details regarding. So it's a 3-part picture, by the way. And so what I would like to now do is begin discussing this from the point of view of what Amazon thinks, or rather Amazon Web Services thinks, is how a retail e-commerce operation should be set up in the cloud from their perspective. So that's their recommendations. Most of these guys are recommendations coming from Amazon. The recommendations keep evolving. The good thing about this thing is that, if you look at the Amazon's retail website, which is what you're looking at here, and I occasionally go there to buy stuff, but that's what I'm talking about in terms of what Amazon thinks should be the implementation of a retail website. Now let's go see other things. The AWS architecture is something that I would like you to go to this location called Architecture Center. And this is the place on their website, which is where they host a whole bunch of information, whole host of information. And it has evolved quite a bit over the years. And I have seen its evolution. And here you will find interesting things. For example, variety of AWS solutions, like here in the middle section, AWS solutions. If you go there, you will find solution sets by industry, or solution sets by application type. So if you're looking at a particular type of application, they will give you what their recommendations are in terms of how a particular application should be constructed or set up in the context of, yes, Amazon's cloud, because this is Amazon focused. Or you can look at by industry. And so you can go and understand what would it take to, solve the problem of, your enterprise IT, for example, and what problems enterprise IT have, and what are the typical use cases, and how do you go about implementing those things in the context of Amazon's cloud. So that is this idea which I'm talking about, is the Architecture Center, AWS Architecture Center. That is a keyword I think you should go and search on Google, and that is a good source of information for general purpose reference material as to what Amazon Web Services thinks is how businesses should be doing, or rather how companies should use Amazon's cloud. That's how it's basically a marketing website, but with a lot of good information. So I actually take this, I consume it, but of course I take it with a pinch of salt. Sometimes they put in a little bit of spin and make it appear that it's possible to do these things only in Amazon's cloud. That may not be the case, by the way. And so what has happened over the years is, just like this AWS Application Architecture Center, other companies have caught up. Now, for example, here is Microsoft Azure architecture is there it is. So this is the set of solutions that basically in competitive response to Azure, from Azure to Amazon, is this site, where they have also done similar effort. And their pictures and illustrations and architectural diagrams all talk towards addressing the need of either a given industry or a type of application, or how you would do things if you were doing those things in the Azure cloud. So most of these pictures, again, coming from Microsoft, are designed in a fashion that will make the reader believe that this is possible only in Microsoft's Azure cloud. And the last person, or rather the last company, which has also come along, as you would expect, to do the same thing, is the Google Cloud Architecture website. So Google Cloud Architecture also architecture. There it is. So that should bring up the right location, I think. Oh, they have too much on certification. Yeah, that's not, none of these links are right. So I'll get the link for you, but there is a link in which they describe how things should be done in the context of Google Cloud. And so it is focused on marketing spin towards getting a solution, getting a product, getting a solution to a problem as implemented in these clouds, Amazon, Microsoft, and Google. So that's their perspective on how to do things. What I will like to do today is remove that piece that is marketing in here and give you the actual story about how you can do it in a choice location of your choice. Like, how would you do these things where you think is the right place? And how would you go about making that decision? What to take here, what to keep, what to retain, what to maybe take it with a pinch of salt. How do you go about thinking these things? That's what I would like to focus on. So we have three big companies giving their recommendations, trying to push their solutions. And it's okay. I mean, let them push, but we don't need to seek the whole thing. We need to pick and choose very judiciously and methodically as to what exactly makes sense for our case, in our business context, for our customer, our employer, and go forward with that. So as a first example discussion I would like to have is, again, back to the concept of e-commerce websites. How do we construct a classic e-commerce? And Amazon.com itself is an e-commerce site, as you know already. And so here in this picture, I think let me just dump these pictures out to you, or let me see if Travis has already done it. I don't know. Let me just check. Do you have it already handy?
I don't really have many of those.
Okay, hold on. Let me then grab it and I'll just start dumping them so that you have access to it. Otherwise,
aren't all these pictures on the AWS website?
the problem is it is kind of hard to find.
Oh, I was able to find them pretty quickly.
Then dump it, please. Please dump links. If you're able to find them, that's awesome.
Okay.
I was not able to find. I tried, I could not find them. Like, for example, the e-commerce ones. There are 3 pictures like that. If you find them, please post a link in Slack chat. Thank you. And let's go discuss this thing. So from the point of view of a customer visiting an e-commerce store, there are basic things that are expected. Like, what do we expect a customer who comes on a website, lands on a site, typically looks for something, looks for a product or a service. So there has to be a list of some sorts that contains a product or a service. So a list of things. Could be list of products, list of services, list of something. Basically this list is stored in a catalog of some sorts. The product catalog. And when it comes to cataloging, and it's a large collection of things that you will find, you will need to have some kind of a category, categorical listing. So you should be able to basically do a search and sort and go identify a particular pinpoint, a product that you know. I think you know these things already. If you compare what I'm talking about with the actual Amazon site, it will look something like, let's go to Amazon and find what I'm talking about is the product category. So you see it right there here in the all section. All departments and Alexa skills and this and that and appliances and baby and clothing and courses. They have courses these days, huh? Interesting. I don't know what courses are you selling here, but apparently they are selling some courses. And so here is the access to the Great Courses course, the Creative Blog, the Creative Live, edX courses. Interesting. edX is now on Amazon. Okay. So Introduction to Linux. I mean, they're selling a course for that for $99 from EDX. So that's a catalog that you looked at here. So you go here and you select the department of your interest. And then you have a way to sort that further. You can select by price, select by reviews, and other types like books and courses related items. So that's the concept that I'm describing briefly, basically about this. Where is the picture? Where is my picture? Here. Is this categorical listing of items, products, or services of a variety of nature is what the customer is looking for typically. And so from the point of view of the customer who is hitting some kind of a service, basically the website for e-commerce, they will look up the DNS query, the first thing, and then hit some kind of a front end. And that front end typically is, where is the front end here? So this is the checkout application. Am I on the right site? I think. Okay, I think I need to go back to that. There are some pieces missing in the iPad discussion that I don't like it here. So that is something that I'm abandoning my iPad effort and going back to my usual ways of doing things. This did not meet my condition, my my taste of doing things does not fit with this. So I'm stopping my screen sharing here and going back to the old ways. And here it comes. So the web front end that you look at here is what I was discussing, and I'm going to project it from this computer, which is what I'm projecting right now. Off it goes, share my screen. And there it is projecting the same thing that I think Rob just pasted. And that is the picture I'm talking about. So the point here is, if you look at from the perspective of an e-commerce website, there are a couple of things that we need to have in hand for it to succeed from an end user's perspective. And if you look at that perspective from the point of view of, let me just let me get my bearings straight. I think this change of screen did not work out very well. So let me get it right. Okay, where did it go? E-commerce, checkout service, e-commerce website, and e-commerce marketing. Okay, so the three things that I'm really talking about. Why is the font size not correct? And this should be adjusted. Okay. So from the first picture perspective, the front end perspective, the web front end perspective, what we need to be able to do is have a place where we actually store the catalog. And that catalog is what we just discussed briefly in terms of, product listing, the categories, the tags, pricing, availability, ratings, things of that nature. And that should allow the customer here to be able to look at the choice of the product that they are pinpointing at, and an internal search engine that actually helps them search a particular item within the product catalog, which is they are showing as stored in a database. Now, this database doesn't need to be DynamoDB. It can be any database of your choice that you like. And so there are lots of choices of databases available. You need to select what your application actually is able to handle the best and use your choice of databases, your choice of search engines. So the typical choices in the open source domains will be Elasticsearch for a search engine, Elasticsearch as a product available in the open source that is typically deployed together with some database like MongoDB or maybe PostgreSQL, Postgres or Maria MySQL, those guys. That's the typical deployment you will see in most cases which are using open source products. And it is completely up to you to select the data store. Once you have a data store, you need to have a method of letting the customer search for a particular pinpointed item. I mean, that one item that I'm interested in, I want to grab that item out. And that is what I want to be able to have this e-commerce application present to the end user customer as when they look for a particular item from a search perspective. And so that entire experience of looking at a particular item. So specifically, for example, if you open a browser and go to Amazon.com, that's what we are really doing. I pinpoint, let's say, where is that? Some product. So I want to buy maybe this Quicken product. How about that? So I want to go do my taxes. So I select that product, and I am focusing on that particular item. This item has a unique index number. That index number in the case of Amazon is called, it's called ASIN right there. You can see it here. This number is the index number in the catalog. ASIN is the Amazon specific index number or item number. And that number is unique across the entire e-commerce site. So this ASIN number is what you will see identifies that one item entry that I am interested in currently, which happens to be this tax software that I was looking at and searching. So the search engine will help me bring it up, that item up front, and present to me through the e-commerce application that I am looking to explore and maybe potentially buy. Maybe I want to do another thing, which is find out what other people may be doing instead of buying this product, the one that I have in mind, which is Quicken Deluxe 2018. Maybe there are certain other products that suit my need better. So Amazon will, or rather the e-commerce application on the back end will already understand that the customer this time, the visitor this time is potentially interested in solving the tax problem, which is to be able to file the taxes before the deadline. If that's the idea for the customer really trying to actually file taxes, right? So depending on that situation, that Amazon or the e-commerce site needs to understand that they need to be able to be presented with other possible choices or ways to solve the same problem. And there is one thing that I would like to point out here, which is an important thing to remember, is when people go to, say, Home Depot, and they buy a drill. What are they really buying is not a drill. What are they really paying for is not really a drill, but a hole in the wall. A hole in something. That's what they're really paying money for. So they buy a drill, they buy bits and other things that go along with from Home Depot. What they're really trying to pay for is this hole in the wall that will actually solve their problem of maybe hanging some scenery or beautiful picture or something like that. I don't know what they're doing, but that's the goal that these customers have. So you need to understand this underlying logic under the hood. Like, why are people paying money? Why are people buying a drill? What is that thing that they're trying to solve? So that's a hard problem to understand from an e-commerce application perspective. But that is what Amazon, or rather this website, will attempt to solve. And they will attempt to suggest alternatives available right there. So here, this is, I think, advertising. So this segment is advertising segment, but here is the other idea. What other items do customers buy after viewing this item? They're trying to give you a hint as to what alternatives are to this product, which might actually solve your problem, maybe in a different fashion, or maybe better at a lower price or something else. And they give you this recommendation set, which is customers who viewed this item also viewed these other items. Apparently, it's all full of the same Quicken company, but there should be something else other than Quicken, but apparently not. I think Quicken is the king of the jungle here. Looks like it, because I don't see anything else. People who use Quicken apparently only buy Quicken. There is other products available that they're not showing it for some reason. They should, but they don't. So this idea of showing a recommendation, like I mentioned here, is when you look for a product, you should be given a set of recommendations to go along. Its recommendation is to be run as a separate service to go along with the particular item that you search for from the catalog, that you need to actually generate that recommendation through a separate entity, which is here, which is the third picture that you see in that list that we have, is the third picture, which will actually generate a recommendation and also present that recommendation right to the user in form of either a separate frame or within the same page that the customer is looking at. And so the customer not only looks at this particular product that they're interested in, but also given a list of things that they may also be interested as a recommendation. You have to generate that recommendation almost instantaneously. And that is what this piece of puzzle, which is the third picture in this part 3 picture that you will look at as we go along, as we describe this. Now, in here, you will see that there is the Elastic Cache item, which is basically storing catalog cache in transient session store. Now, what this Elastic Cache does is basically it is a in-memory storage or a cache of whatever queries have happened in the past. So that whatever transactions either this customer or other customers that have had in the past, in the recent past, with the data store, this store, that is kept in a memory location using this particular product available from Amazon. Now, if you look at that particular product, it is not unique to Amazon. It might sound like unique to Amazon, but it is not. So if you go to Elastic Cache, that is the product from Amazon. And so if you go and click on that link, this is the product that they're talking about. If you go under the hood and actually go sign in, you will find that this Elastic Cache is actually comprises of 2 products. Both of them are open source. And so those 2 products happen to be Redis and Memcached. So if you go to Elastic Cache, which is in-memory cache, and if you try to get started with it, it will actually give you that option whether you want a Redis cache, which is a in-memory cache available from this location, redis.io. And running this is as simple as running Docker Redis. So there's a ready-made image available. You can just go Docker run Redis and Docker pull Redis, Docker run Redis. That's how you can stand it up very, very easily, effortlessly, and it just does its work. Totally no issues. That's one implementation of the same thing under the hood, the Redis implementation. You can also select this checkbox to have it cluster enabled. So you will see that this thing is actually structured like a multiple machine, large memory machines clustered together to form a big Redis cache. The idea behind this product, Redis or Elastic Cache cluster, are also implemented in another open source product called Memcached, which is the second choice. Also does very, very similar things, but it's up to you as to what your application needs to select between Redis and Memcached. There are 2 choices available in the Elastic Cache cluster. And Memcached also happens to be, Memcached is a product available in the open source right here on this location, which is very, very similar to Redis. And it is also available on Docker. And so you can just say, Docker run Memcached or something like that, to that effect. What these things actually do under the hood is, let's say, EC2 machine type, large memory. So if you look at this machine type here, instance types, large memory instances. So there are memory optimized instances. If you look at here, X1E is one type and X1 is another. And there are other ones which are, I don't know if R type is also memory optimized or not. I think it is. R type, R4 is also memory optimized. So these 3 or 4 different types which are memory optimized machines are specifically focused on very high amount of memory. You can see that the number of memory, 3904 GB memory. The disk may be less, but the memory size is huge. That's structurally how it is defined as optimized for memory consumption. So these are the underlying machines that you would typically deploy for a large scale deployment that requires a design which needs to cache. Cache what? Cache queries that this search engine is actually caching from the store of the data store or the catalog or product catalog, whatever you have in the product catalog. People come and search. They use Elasticsearch, and that query that you are running from the customer's point of view, it needs to be cached simply. And this is a necessary thing to do because, or rather, if I say, can you tell me why is it important to cache those queries that people come and search for products? Why is it necessary to cache that thing in a large, high memory cluster of machines running Redis or Memcached? Why is it necessary to cache these queries that you do here in the store and keep them in a session, in a transient store, in a memory store, basically high memory? Why is it necessary? Anybody?
So this is basically like Oracle pinned queries, right?
Yes. Yes, that's one good example. Beautiful. The core idea here is that you don't want to bother.
Say? What kind of query?
Pinned queries.
So Oracle allows you to pin a query along with the results into memory. For faster access.
It's for performance.
Yep.
Yeah.
Yeah.
It's speed because disks are slower than memory.
Yes. So this is basically slow. This is disk. And this is memory. So you're talking about high memory machines running Redis, running Memcached, or in Amazon's language, running Elastic Cache, and you don't want to hit the disk too much. You maybe just hit the disk as only when needed. And so that is the idea of not hitting the disk over and over. If you have a query that is already executed at least once by a given customer in the recent past, you cache it. And then you use, next time the query will be served directly from the memory as opposed to from a result from a database.
So you just said
second,
an interesting thing. So the first time query has to run against the database, right?
yeah, first time it has to go to the database, no doubt about it.
Okay, so it's not like it's not like it's sucking the data out of the database and storing it in the.
No, not by its own.
Oh.
That doesn't make sense.
Okay.
Because there is petabytes of data here, there is gigabytes of data here, so it doesn't make sense to fit. It won't fit.
Okay.
So you pull the queries that are first executed, somebody executed like 10 days ago, 5 days ago, maybe two seconds ago, something like that. You query that and you copy that query with its result right here in the transient session store, which is in gigs of memory. So you saw like some gigabytes of memory right here, right? How much? 3904. It is still gigabyte, not terabytes. Disks are typically in terabytes. And this database Dynamo is a database. I mean, come on, it's a disk. So it won't fit in the memory, by the way, the whole thing. It may not. But certain applications like SAP HANA, as you will see as an example, HANA in a future example, you will see that this entire processing of the SAP pipeline, especially in the HANA product, is done in memory, not in Elastic Cache, but in a high memory machine, not in this exact product. But that's another way of thinking about what needs to be stored in memory versus on the disk. You don't want to hit the disk too much. Ideally, you want to not hit the disk at all, but that's not technically possible. So you minimize the hits to the disk and serve from here as opposed to from here. And this search engine will actually do the query part and get the results, and result will be stored here. And then sometimes things change. And what if the product availability changes, the product price changes, some things about it change? Then some other application has to actually update the catalog. And when they update the catalog with a new product or a change of the product or change of the product's picture or product detail or price or availability or something else, that product data stored in this database has to change. When that thing changes, you need to remember to invalidate this query corresponding to that product. This has to be invalidated. Otherwise, the customer will receive old data, which is not what you want. So anytime you have a cached session, you want to delete the transients. These transient sessions that are stored here, you want to kill them out. That's something to remember from a usage perspective of an application that actually uses cache. So as you look at this picture, there are tons and tons of caching going along every step of the way. So let's go see the very foundation. Here is your disk, which is inside the disk. There is some memory in the disk itself has some cache. If you notice this, some disks will mention that they have cache in there. So there is caching going on between the disk, within the body of the disk itself, and the SSD portion and the cache portion of the disk. That's one level of caching right in the disk itself. Now comes the data store, and the search engine will search and query and put the query results back in the in-memory cache of some sorts. So that's the second database level queries. In Oracle's language, they call it pinned queries, stored sitting right here. And that will be served when a request for the same product from a different customer comes along, and this customer asks for the same item. That query will come from here. That's the second level of cache right here. This is the database cache. Let's see further along the way how many caches are involved in the picture. So here is this e-commerce application. That application is typically some kind of a smart application that actually is able to help you search, help you present the resulted picture that looks like, where is that? Like here, for example, this is a result of an application generated HTML. It painted the picture like this. Now what I want to talk about next is that entire application has to send this HTML out, which requires some kind of a web server like Apache or Nginx. So that Apache or Nginx needs to also identify that the HTML constructed by this application that looks like this picture, for example, which has, this screen, for example, which has this picture included here. As you can see that there is an image of a Quicken product. There are some details about it, some title and some HTML and some JavaScript and some CSS included in this entire page. So that component of HTML, CSS, and JavaScript, some of it is repeated over and over again. For example, for different products, there are certain pieces of here that are repeated. And let's go see what is repeated. So we'll go here and let's go see just some other product. So I'll go to, say, today's deals, and we'll find out there is this product called whatever this thing is, laptop. Yeah, so see the end, and the deal is not available apparently for some reason, but whatever. So this picture of the logo, Amazon Prime logo. So you see that image here, the section of this, the black colored bar on top, this segment, the footer portions, this segment back to top and all the way to the bottom, this segment, the entire bottom portion is repeated on every single page. So certain components of this page are repeated over and over, and certain others are not. So what does that translate to from the application's perspective here is that it can identify certain constructs of the HTML, CSS, and JavaScript and make sure that those pieces that are repeated over and over in every page are not asked by the customer over and over again. So what do they do? Or rather, what should you do is to make sure that those components should be sticking here. Stick right there in the browser of the user. I don't know, did we discuss this idea of browser level caching before or not? Did we? I don't remember it. So let's go pinpoint all the possible places where people can cache. And I'll begin from the company on one end, and on the other end, this poor user. The user has a browser, typically most cases. If this is repetitive, please tell me. I don't remember having discussed this, but I think this is important to understand the caching along the way from a source to the destination. So from source to destination, there are multiple levels of caching, and let's go divide that into two parts. So the company side, which is the sending part, and the user part is the receiving side. So they receive content, right? So let's go see here on the database aspect. So there is a database here. There is typically some kind of a disk. The disk typically has some cache. This database is typically, the database queries are stored in some kind of a Redis-like cache. That is another caching. So that repeated queries in Oracle's language, they will call it pinned queries. Repeated queries over and over done that are stored in some kind of a Redis or memcached type location. In addition to this, this company that is serving a page needs to also produce some kind of a imagery, some JPG or some PNG files, some CSS, some JavaScript, some HTML has to be constructed. And that will constitute your web page that the customer looks at, like this, for example. So there is this item and it has some detail like this and some pricing and all that. So the idea here is this picture, this PNG picture, the CSS, some of it is most of the time reused over and over. Not the picture part, but some CSS in JavaScript is repeatedly used. The same CSS applies to the entire site sometimes. The whole styling of the site, the whole set of JavaScript files that this site is currently serving to the user. Those files, CSS and JavaScripts, are typically given out to the browser at one time, and they just stick right there. They stick in the browser cache. Now, before they reach the browser, there are other places that you may already know. This is called the Content Delivery Network, which is another cache. And the CDN, as you know already, you have done exercises with the idea here, is it caches. It caches until there's a user who needs something that they will actually go and ask for the origin. Hey, give me the thing that the user wants, and the CDN will cache it locally in the CDN location. And when the user asks for it, another user asks for it, second or third user, they will give that content directly from the cache, as opposed to going all the way to the source of the JavaScript file, or source of the CSS file, or source of a particular picture. In fact, if you look at this JPG, in any JPG, or the easiest way to look at it is actually in this site, so I can actually give you live examples, which you've seen already. This guy, if you copy the image address, is coming from a different location. It is not the Cloud Genius website. See that? This is a C dot some other location. It's a CDN location. That's what I'm talking about. This picture came from CDN, even though the actual origin is this location, B.A. Cloud Genius. That's where it's coming from. But to me here, I see it is coming from C. Cloud Genie. Yes. So that's the idea of CDN caching. Now, even before that, there is one more thing that I want to talk about. We talked about database caching here, DB caching. In your Redis or Memcached, we talked about these things. You want to be able to compress, minify, or in other words of compress, the idea of uglify is also used sometimes. Uglify, to make it look ugly to a human, so humans don't find it easy to read. It is still possible to read, but it is just ugly to look at. And I'll tell you what uglification means. And uglification reduces the size of the item. Minification is also reduces the size of the item. So it reduces the size of the JavaScript, CSS files. And there is also another idea which is called concatenation. Concatenation basically means put multiple files together if possible. So instead of sending one file at a time, so this JavaScript and that JavaScript and this CSS and that CSS, too many queries going straight to the browser at the end user's point of view will slow down the site delivery. So from a performance point of view, you're looking at multiple levels of caching. One is right in the browser itself that you talk about all the time. You clear browser cache to clean up the cookies or other state that may be sitting in your browser. That's one cache. CDN as another cache. Now on the other side, this machine that is sending you these items like JPEGs and PNGs and CSS and JavaScript are compressed and uglified and minified and concatenated and are then stored here in CDN on demand. They're actually stored at the origin to begin with. But let me show you what this thing from another example point of view, what I mean by minification, concatenation, uglification. So those ideas are important to understand because we have never discussed these things. And that is a necessary thing for performance. So I'm logging into the website here. And this is, by the way, a place where I think somewhere in the caching pipeline is where I have a bug in the Cloud Genius website. And I'm not able to pinpoint where exactly that bug is. So it raises its ugly head occasionally on some of you. You have seen it in the past, maybe one or two, is that you have to log out and log in back again. Otherwise, you see this image that shows, hey, you need to buy the course. That is a cached in your browser situation. It can be cleaned by the browser cache getting cleaned, or cleaned by the CDN cache getting cleaned, or cleaned by removing this compression, uglification, minification, concatenation. Either it is a bug somewhere here or somewhere along the way in the pipe. But those are the things that I'll describe. I'm implementing these things to the extent possible. But now you will see the idea, which is minification or uglification, concatenation, all together handled by a plugin. That plugin is AutoOptimize. AutoOptimize. I'm not spelling it wrong, but it will pick up correctly, I think. No, I did not. Auto optimize. So that is a plugin. What this does is you can see the source code of it. It's available somewhere in GitHub. Where is that? No, not showing you the GitHub link. Oh, how interesting. So auto optimize GitHub. And so here it is. Here's the source code of it. You will find in here that it is actually doing what these 4 things that I mentioned here: compressing, uglification, minification, and concatenation. Let's go see its view as to what it actually sees, what it actually does when I use it, because that's the
When you
easiest
say
part.
Uglification, is that obfuscation or is that different?
Sorry, say again.
Did you, when you wrote down uglification, is that basically obfuscation?
Uglification.
Obfuscation, is that basically obfuscation?
I think the obfuscation actually changes some of the calls around and adds in kind of like, circumlocution, essentially.
Yeah, it helps make it so you can't decode it.
Yeah, so the uglification doesn't involve code changing.
Yeah, obfuscation at the root level shouldn't either, but it basically makes it just harder to decode.
There is no code in uglification, by the way. So there is no coding as such. So let's go see an uglifier. There is a library called Uglify, which actually does the uglification. And here is the library, which you should use. Your project that you showed us today actually uses Gulp, I noticed.
Yes.
So it is Node.js. So you can actually include this library in there to uglify your JavaScript to make it a little bit faster for the end user. So this is Uglify.js.
Yeah, we do something like that, but we do it so that it's not as easily, so it's some protection in, so that nobody can just read it. They have to kind of like decode it and make it, have to spend time decoding it.
Okay. My way of thinking in this direction is that it's okay to use it, but don't waste time in unnecessarily coding, decoding, because it's kind of pointless. At the end of the day, people who want to steal your content will steal your content. I mean, you don't want to prevent them because there's no...
more along the code, not the content, but yes, I understand.
Yes.
We just want to make it a little more difficult for them to just out and outright steal our stuff.
Yeah, makes sense. But my way of thinking is slightly different in that what I worry about is those who matter. And I don't worry about those who don't matter to me, because there are people who will steal your content and don't worry about them. I mean, they'll always be there, right? People will steal. And so they are not your target focus. So I focus on those who matter to me and I ignore the rest. That's how I think. Maybe it's actually, it's a choice of a personal way of thinking. So I'm not suggesting that you think like me, but my way of thinking is very simple. I just ignore the rest and I focus only on what matters to me, or rather to my customers. And that's how I operate. I ignore at the cost of letting somebody steal, I let them steal and put it on Pirate Bay, and that's okay with me. I just said that. Because it's irrelevant to talk about other things, because people who steal will never actually become your customers. So why bother? That's how I think. But that's just business. Now back to uglification is this idea. There is minification, which is simply think of minification like this. Let me just write some HTML here. Oh no, not this. Here. So let's go write some HTML. So I write HTML, and this is very crude right now, but just bear with it. Head, and this is the end of the head, and then this is body, and this is hello, and this is the end of the body, and this is the end of HTML. So this is HTML, for example. So some simple HTML. That's my expanded form. If I want to minify this, what will I do? Is simply remove the white spaces. like that. And that is the idea behind minification. So by minifying, what you're doing is improving the download performance of this particular file set, like that. So this is classic minification. And I save this file as my HTML file. It's hard to read, but of course you can beautify it, just like, there's beautifiers, HTML beautifiers, HTML beautification. And there are beautifiers available online, like there, for example. And you can just copy and paste some ugly HTML and say format, and it will make it clean for you. And so this is the beautification thing, which is the reverse of uglification or minification. What these things actually boil down to is performance. So that's something that you want to make sure that you compress, uglify, minify, concatenate, and there are tools available for you to do it. In essence, you're compressing the whole thing in one shot, ideally one, if not more than one, but let the CDN grab it and keep it for you, keep it for the customer, so that the customer can then receive whatever you're sending to them.
So,
Along with, yes.
So realistically, it matters only in the high volume transaction environment, right? Like Amazon.
Yes, yes.
Boeing does not have near as much traffic as Amazon, not even close.
Yes, true. And Cloud Genius has not even as traffic as Boeing. I mean, no comparison. I got like 25 customers. So
Okay.
yeah. So, but you know what? I still do caching. You see me do it, right, all the time. Why do I do that? And that is something to discuss and understand. Caching is not just for the purpose of, so let me just show you a real live example where I will disable caching right now and show you some metrics of how it is important. I actually disable on the live website. So there is Justin saying something, minification in action. Beautiful. Thank you, Justin. Yeah, you should click those links and you can see that here is the full jQuery expanded form. And the other link that Justin has given us is the minified version of the same jQuery that is looking like this. So this is the minified version of the same jQuery library available from code.jquery.com. And this is hard to read. This one is somewhat easy to read if you can read JavaScript. So the same idea, beautiful example, Justin, thank you. And see, the same file is compressed, or rather minified, to make it easy to transmit on a large network. So you're saving some tiny little bytes to help you with something. Let's see how it actually boils down to from a performance perspective. So here is the site that we use. And yes, I'm a very, very small company, as you know already, tiny small. But let me just understand what does it do if I just disable my caching and see how performance metrics actually take a hit. And it is important even for small people. And I'll tell you why, and you will see it. I hope I can demonstrate a live example by disabling certain activities. Like I'm disabling my optimization. I'll also disable my CDN right now. So remove those pieces. And so I'll completely unoptimized site is what I am going to show you. Right now I'm disabling the content delivery network also. There we go. And it is also disabling. Right now my site will not suck. It'll not suck, but it'll be slightly slower, tiny bit slower. And let's go examine whether the site actually functions correctly. So I will go now to the different browser, and because this will probably be not cached. So I'm going to clean up the where is the thing here? Preferences and privacy and security, and clean caching completely out, and cookies completely out, and that's clean browser, empty browser. There we go. And now I will start the browser again. And what you will see now is I'll open that website again, the CloudGNS website. It's opening up, and you will inspect how long it takes. I just hit enter for that website. It took me like 7 seconds to load. Typically, it loads in like a second or two if I have repeat visitor. This visitor was the first time visitor visiting the site. If I reload it, it will still be slow. See, I reloaded, and I'm waiting, counting 7-8 seconds or something like that, and it's still not properly loaded yet. Now it loaded, like 10 seconds of reload. So that is the amount of time that I'm wasting on every transaction, every person hitting maybe this link or that link or something else will waste about 10 seconds on a click basis. What if I'm able to optimize this performance? And you will suddenly notice that the site is somewhat slow. It will be hard to diagnose this unless you actually test it. So let us go test this site performance. We'll go to a testing tool. And here it is, opening up. In that tool, what I'll do is I'll grab this URL and say, you please test the website from, say, San Jose. So go test this website from the San Jose location and give me a report. We'll start the testing. It should take like 10 seconds, 30 seconds or so and finish it off. You see that the test is proceeding forward and it has disabled caching and disabled content delivery network, and every other performance caching has been completely turned off. So the site load time is currently at 9.25 and the site is performance grade 67, which is a D grade performance. It is faster than 14% of tested sites, which kind of sucks. And here we are not combining JavaScripts. There are 32 JavaScripts served from the CloudGenius website. Wow. Why so many? Because that's how the application is written. That's how we have. So there are lots of JavaScript. That means there are 32 queries going back and forth between the client and the website. And that is slowing down somewhat because there are so many queries involved in making sure that it actually serves properly. So the combination of JavaScript files into one or two files will be an ideal situation. Then the other idea here is there are 103 parallelizable requests. OMG. And all these pictures that you see on the front page, these are the pictures. So lots of little things, mostly pictures and some CSS and some JavaScript are total of 103 that can be parallelized, not paralyzed. And so the other suggestion here is leverage browser caching. The idea here is these assets or these HTML, CSS files that I'm looking at, there are lots of them, and pictures. I am not leveraging browser caching. What is browser caching? Is recall is the same idea here. Browser cache, which means I would like to make use of the resources the user is providing to himself. The browser, it has a cache and I'm not using it. Why not? So let us enable browser caching. How do you do that? You let the browser know that, hey, I would like you to please keep a copy of this thing until the next time I change it, until I tell you so. So yeah, I will basically notify the browser by doing certain things. For example, let me show you an example of something that will give you an idea about how you talk to the browser to tell the browser, hey, keep this or no, don't keep that. You notify the browser by letting the browser know of certain things. So I'll pull up some things that are currently have browser cache and the others that do not. And let me see if I can find an example. So here is a picture. Let's see if it is already, yeah, I think it's a good one. So curl -I, get the header for this. And you will see that it has a cache control max age entry and an expiry date. This expiry date is March 13. You see that? I just queried some picture and found out its header. It's a different site, by the way. And actually, I'm going to the CloudGenius site, but from the CDN portion. So this is the C dot. So the CDN representation of the picture. Actually, if you go through the CDN, it is advising you to cache, advising the browser to cache this object until this time. That's the way the CDN is communicating to the browser to please cache this picture and keep it with you. The origin of this picture is coming from here. So that's the idea underneath, under the hood. Now, if I look at this picture itself and go straight to the website, you will find something that is not currently enabled for any kind of optimization and no browser caching. I think let's go confirm that piece. So I will confirm the word employer, and this file is currently being reported as leveraged browser caching. They have a very short lifespan, which is a complaint. It's a complaint as if I am not leveraging browser caching. And that is correct because I've disabled browser caching, right? So I'll go back here and now curl this link that I have grabbed from that website, the complaint that you don't seem to browser cache. And so I say, okay, let's go see what it says. And you will see that something is missing from here. Can you tell what is missing? Or maybe not. So let me go side by side and show you what I think. You can tell what is missing. So let me just adjust the font a little bit and run the other query right there. You will see certain portions are missing in the first segment. Currently, the site is showing you this, whereas it should be showing you this. And that is, these pieces are missing. That piece is setting the expiration of this object in the browser's cache. Because that picture, the employers.jpg picture, doesn't change so often, right? It should not change so often. This picture should not change so often on a daily basis. So I keep a 7-day expiration period and I keep this picture in the browser's cache. It's a great thing to do it like that because I am actually saving money. Tiny little bit of money, but yes, there is saving. And I'll tell you where it comes from. It comes from the fact that this item picture, which originates from the source, is actually stored in a CDN and doesn't get sent to the user over and over and over again with every click, because the user will come and click and they will actually go on this website. They will hit left and right wherever they want to go, hit there, hit here. Every time that picture might pop up in some location, like this picture pops up. If you right click on this picture, copy the image address, it will not have the CDN entry right there at the top. You can see it doesn't have CDN because I've disabled it. And so if you now look at that same picture again here from the command line perspective and examine its header properties, you will see that it is missing the cache control directive to the browser. Whereas the other representation, which is the content delivery network representation, actually of the same picture, actually has that directive right here. And these directives are generated by your web server. So this server, the source has to originate and put this directive in a header for every object that is eventually compressed, uglified, minified, and concatenated and served to the user through a content delivery network. And that directive created here needs to be replicated here so that it is actually sticking to the browser cache. That's what this picture is really trying to communicate, which it doesn't go into great level of detail about what it is done and how it is done, but there is one caching, which is the database level caching. The other caching goes around right here in the web HTML, CSS, JavaScript layer. And this content delivery network you're looking at also helps the browser stick the item, that you don't actually go and ask for the same JPG over and over and over again, because there is the saving right here. You know what? CDNs are expensive because they are global and they take your picture wherever you want it to go, depending on wherever your users are. And so an example of that, a practical example of this will be something like let me just see if I can find a bill to show you as to where the saving comes from. And so let me see if I can find my bill. Bill, what is it called? Invoice? Yes. So here you can see that this is a monthly operation report. And you can see that we have a person coming from Singapore, as you recall. And so there is some bill corresponding to Singapore. Let's go find out where it is. And why is it a Singapore specific bill? Because the user is there. I mean, we know Ramesh is there, so he's hitting it. And there's a consequence. There is a reference. Where is my detail of the bill? The PDF file I was expecting to see in the bill, but it's not there. Where is my PDF file? Okay, let's go see the Google Cloud bill. The bill should show you exactly which regions are hitting your content, and it will actually show you some extra charge for that particular region, which otherwise there are no customers apart from Ramesh. But because of him, there is a cost to it. I'm not complaining about the cost, but I'm just pointing out that there is a cost. And so don't get me wrong, Ramesh. I'm not saying that you are causing me an extra bill. That's not what I'm saying, but just want to point out that there are some charges that accumulate. If you go look at, where is the last month? Not this month, the previous month. Go to billing, and where are the previous month charges? Transactions, maybe. Okay, previous month, that should be a good indicator. And so here you should see a Singapore charge coming up right there. So there it is. The compute engine network inter-region egress from Americas to Singapore of 0.549 GB bytes, source from my production server, from the production region, whatever this project that I have, and it costed me 7 cents. That's a cost. I mean, it's a tiny cost, but it's a cost, and it's actually visible. There is 1 cent going to Virginia, apparently, and some into China. I don't know why there is nobody in China. Maybe there are people visiting from China. And that's what you're looking at. So this 7 cent actually is a small number, figuratively speaking, but in the overall context of what I'm dealing with, the total bill, $213 for the month of February. This is not zero. I mean, it is still non-trivial. As you scale the business, the reason I'm showing this is not to save you 7 cents, but comparing Cloud Genius with a larger company, you will have these numbers accumulate and grow. And so the core idea to remember is to optimize to the extent you can, because if you don't cache, it is going to be a cost to you. And not only that, it is going to be slower for your customers. So they will not only hate you, but you will also end up paying more if you don't cache. That's the key thing to remember. So caching is not just good for your performance of the end user, but is also actually helpful to save money, because you're unnecessarily not sending traffic which doesn't need to be sent. So then you use the laptop. This guy has a laptop, right? This user, use the machine that they have already. And so just keep your asset that you have here, the picture, the PNG picture, the JPG picture. This person visited that website. Just store it right there. Keep it here. So the next time the user visits, you will see that the performance greatly improves. Now you saw some performance metrics showing up on this result sheet, where it tells me that I am a D grade site. I mean, that's what you see. Now let us go see that site again, and I'll enable the tools that I use for caching and see the difference in performance. So I will go back to the website and toggle that button to enable caching, enable optimization, and let it stabilize just a minute, and then we'll go and test. And you will see the difference in ranking and rating. So here is the list that you were looking at. I'm activating this plugin, which enables the concatenation, minification, uglification, and all that thing together. And then the second plugin is my WP Rocket plugin, which enables the content delivery network for me. So that also starts up soon in 3, 2, 1. Come on, there we go. And I had to clear the cache and also clear the auto optimize cache. So there's one more cache that I want to clear on that side. Delete cache. And one more time, I will delete this cache and let the cache rebuild. So I'm cleared the cache again and let it rebuild in a minute or two. And when it rebuilds, you will see that the performance metric from the outside perspective will actually improve, and it will be measurably different. It will not probably not be noticeable to a common user. You may not see it visually. You may see that, what is Nilesh talking about? It doesn't even make sense. The performance is same. Yes, it might appear to be the same, but let us go compare numbers as to what it actually says. And so this is the site. I will leave it up in this window. I'll open another window, and I'll now test that website. Again, same site one more time. And before I test this site, which I did, I will test it again in a second window here. And I'll also test it again from San Jose location. And before I hit the test, I'll actually warm up the site just a minute, little bit. Warming up means actually exercise the site. So I'll go visit that site and check it out. And like common users do visit, I'll do the same simulation for like a couple of clicks. So it loads up properly and caches the whole thing across the way towards the end users. So I'm hitting this website in multiple places and just making sure that it loads properly. Even after this caching has changed, we have now turned on caching. And so that's what I'm visiting the website from the first time user perspective, hitting these pages. And you will suddenly see that the performance of these pages have magically improved. I don't know if you notice this or not, but I do notice that suddenly now every load is quick. You saw that 1, 2, 3, front page, bootcamp. It's fairly quick, relatively speaking. To me, I can notice. I don't know if you notice or not, but I think it has warmed up the cache by now. So I will go to that browser and hit speed test one more time. And here we go, starting the test. And we have a comparison between before and after. We'll see how the load time improves and how the performance grade changes. The load time seems to have cut in half. The performance grade is now B. And so let's go to side by side. So here we have before and after. This is before. And the other one is, come on, this is before. And this is after. So let's go them side by side, review. And see what it says. So there is visibly some noticeably, I find it different, but I don't believe a person like myself. I would rather believe the test. So I can see that the performance grade has improved from D to B. The load time has approximately cut in half. Site is apparently faster than 30% websites tested, which is nice. The page size is 2.1 before, 2.1 now is the same site, right? The page size did not change, but the number of requests suddenly changed. 160 before, and now it's 105. Let's go see what has changed. In case of this parallelized download, there are still 51 parallelizable requests. Now here, it's the thing that the first error that we had before was combine external JavaScript. And here the first error was combine external JavaScript. Let's go compare them, two at the same time, these two. Before, the grade was F, as in failing. And there were 32 JavaScripts served from this domain. They should be combined. Furthermore, it says 3 JavaScripts served from this domain, and 3 from this domain, and 2 from that, and 2 from that. So that's the notice that I had. Now I have, one of the things that is completely disappeared is these 32 files. They have been optimized already. You can see that it is actually one file. That file has been compressed, minified, uglified, and served as one shot, so it doesn't complain. Now I have some other files that I'm loading from other sites, like for example this site, which I will talk about in a few minutes, which is the marketing focused aspect, which is the third picture from the e-commerce implementation perspective. We'll talk about that in a minute. The idea here is there are 3 JavaScripts served from YouTube. So I'm using some YouTube imagery or videos. In the front page, you will see that I am actually using YouTube. Those videos are, I think Alex speaks about them. So there is a video from Alex right there. That's a YouTube video 1, 2, and 3. 3 videos, they come up. And those are the files corresponding to that YouTube player. There are some Google APIs that are requesting jQuery and web font. There are couple of files from Google Ads. They're coming not from me, but from Vimeo, which I have a plugin. So Vimeo wants to track how I am using their service. So that's what these two files are from. And there is video, Vimeo Zen CDN, which is a Vimeo site. I think it's coming from Vimeo. Those two JavaScript. So that's the optimization it has already done. You will see further optimizations also happen, for example, in the other ideas of parallelized download across host names. And here it was before parallelized downloads across host names. The number has shrunk. It was 103, now it's 51. But still, it is complaining that you have a F grade because you need to parallelize downloads and pages across multiple domains. And this, I think, is a error in the tool that I'm using. The testing tool itself is bad. How do I know? I know that for a fact because I'll show you how. The testing tool itself is wrong in reporting that this is not parallelizable request. What does that mean? It means that it means like this. You have 51 files coming from some location to this location, and they come one at a time, and that is okay, and that is true in case of HTTP 1.1. But when HTTP 2 is in play, which is what I have enabled in my site, it is a moot point. This parallelization is moot because HTTP 2 protocol already includes and handles multiple parallel downloads by itself, and testing for this is moot. And now let's go to that site and let's go look at the site itself in a different browser tab in full screen and open it up. You will see that this site actually is a complete HTTP 2 enabled site, and you can confirm that by hitting this button, and it tells me this button is a HTTP 2 is active at top level document. The entire website is HTTP 2 already. You can also cross check this in curl. Curl HTTP 2. It will tell you it is HTTP 2 right there. So the whole site is already HTTP 2, which by design of HTTP 2, this parallelization doesn't even, the error complaint about your site is not parallelizing resources itself is a bad error. The tool is wrong in reporting that error because this is already a moot point. We have moved on to HTTP 2 already, which speeds up the delivery of content to end users already by its protocol. So I don't have to worry about it. So that tool is kind of broken in some sense. Let's finish up this discussion, moving on to the others. So browser caching, we talked about briefly. What else do I get a negative mark on? So combined JavaScripts, there are a couple of things that I still have to do work on. This portion also should be combined in one, possibly one. In that case, if that happens, my performance grade will improve suddenly to close to about 90 or so %. And my site will probably be faster a little bit if I buy a slightly more expensive machine from the Kubernetes clusters that I use currently. They're slightly cheaper machines because I can afford to go slower because you don't seem to notice. Or rather, I assume that you don't seem to notice. So may I ask you this question? Do you notice that the site is slow?
Compared to what?
Between the before and after, did you get a chance to test before and after when I enabled, disabled testing, this caching?
Oh, okay.
Did you notice, or did you even bother?
Yeah, caching definitely helped. I noticed it when I was testing.
The caching had?
Yeah.
Okay. Yeah, caching does help, but sometimes it causes issues. Like I'm running into, I know of a bug that I have in my caching algorithm somewhere that actually results in a occasional case where one of you will say that the site is telling you to buy the product, which is basically wrong caching. Bottom line is it's bad caching. So I still have to figure out where the bug is and fix it. Eventually I will do that. But caching seems to generally help. It improves the score, improves performance, and also saves me money, 7 cents to be specific. So small money, but I'm doing this because it's necessary for me to do, to be able to give you an example of what it makes in a larger situation. If I don't implement it myself, it doesn't make sense for me to talk about it because it doesn't become credible. So that's the reason why I do caching. It is actually, esoteric, if you will. But now Justin reports that he notices performance difference. That's a good thing. But I do this primarily to be able to show you the concept because this applies to a larger case, especially when it's companies like Boeing and Microsoft and other big guns. Big people, they need to do this. They do this already. By the way, you do it. I can check your website and show you where you're doing it. I'm pretty confident you already do these things. Let's go check it out. So let's go see one of your companies, not Microsoft, but Boeing. So let's go see what you do. So we'll go take a look at inspect element and find out how you're doing it. And also take the same test that I just did on Boeing.com. The same test before, now I'm testing Boeing.com. And from San Jose location, start the test. Let us see what it comes out with. The load time is pretty darn nice. 860 milliseconds. The site is faster than 91% of the sites tested, which is totally expected. And you are given a performance grade C. Why is that? One of them is these reasons. Combine external JavaScripts. Apparently, you are not combining them. Maybe you should. Let's go see something else. Leverage browser caching. You're absolutely not doing it. Why are you not doing it? I don't understand. You should do it. There is no reason for you to not use the browser cache. It's suggesting you to use leverage browser caching. And if you don't trust this particular tool, there are other tools better than this, by the way, like webpagetest.org. That's a slightly better open source tool that you can use. If you don't trust this particular Pingdom tool, you can go www.boeing.com and test it from any location that you like. There are a bunch of choices available. This is an open source tool, by the way. And you can choose from any device, any location. Let's go choose the Oregon location. Where's Oregon? North America. Okay, there is Oregon location from a Firefox browser and a Chrome browser, a Firefox browser. Let's go test it and start the test. So now, oh my God. Okay, 1, 2, 3 street signs. Next, how many more? 1, 2. Verify. Okay, test. So it is testing. It is another test. So it gives you a different perspective on testing the performance of the site. So this is the source code of this tool itself is available on GitHub. So you can see the actual usage of this tool as to how it does. So it is testing in like 14, 15 seconds, should be finished off. And it runs the same test 3 times and gives you a comprehensive understanding of how the user is seeing and how the load times are actually happening. Apparently, you can see this timeline view of, and overall the load test finished in how many seconds? 3 seconds is the first time. Oops. What did I click? Back. Yeah. First time 3 seconds, waiting for the second test and third test. So the second test finished in 4.8 seconds. The third test finished in 2.9 seconds. And you can see the waterfall of each assets loading up all the way to the browser in this picture. You can see the waterfall view and item by item and go into detail about which particular asset is actually slowing down. So after this blue line here, 3 second line, after anything after that is typically slowing you down. So this picture, which is this Boeing.com, whatever 1280 by 720 JPG picture is like taking so long. This item, this resource is taking way too long to load. And that is something that should be optimized. So we can go further in there and identify. By the way, one thing I noticed, curl on that website. Let's go see. See, you're not using it. You're not using those, cache control and cache expires. those errors will help you. Well, I don't need to tell Boeing to save money, but yeah, you can save money and improve performance of your site simply by storing this picture, whatever that picture is. This picture, yeah, this beautiful picture. You can use the browser's cache, the user's computer browser's cache to store this beautiful picture. The first time they visit, they take a little more time, but the subsequent times, this picture is not going to change over and over and over again on a daily basis. So why not leverage? That is the thing that I would suggest that you please do. Leverage browser cache like this. Where is that? Like this, like here. You can specify item by item how much duration, when is the expiration date, and set the cache control parameters like that. And you can very easily do this in Apache and Nginx and any other thing that you currently run, which I think you do run Apache right there. And so it's easy to do. It's just a question of enabling it. And another thing I noticed is this thing right here. Why are you not using HTTPS? I don't understand it.
Because we're brave.
Okay, let me salute you for that. But you should. I mean, HTTPS is a given. You are brave, and that's awesome. But it's a given that you have to use it. I think there is no reason why you should not use HTTPS.
Nilesh, remember, Boeing sells planes. They don't do websites.
I know, but a website is not what you sell, right? Website is a channel for your customers to visit, right? So if you somehow have
in other words, it's not a priority for Boeing to spend time.
You should. I'll tell you why it should be a priority. I'll tell you black and white. Just listen. You don't have HTTPS, which basically means somebody can run into a man-of-the-middle attack between, say, American Airlines and the Boeing.com website. Those 2 points, American Airlines as your customer, Boeing.com as another, as you. And so in between, if there is a man-in-the-middle attack of some sorts, somebody can show up a picture of another plane, not this, but what's the other company in France? Airbus. Airbus picture shows up here. What would you do? Do you want that to happen? Is that not a priority?
That would be funny.
I know it will be funny. It'll be bad for all of us, but it'll be bad. And that's what the more important point is. It's easy to do a man-of-the-middle attack.
Hey, Dave, aren't you InfoSec? Shouldn't this be in your area of expertise?
I mean, yes, we should not pinpoint people, and that's not the point. The point is to think about how these are important, critical issues. You're leaving a endpoint that represents your company as not HTTPS. That means your services that you are interfacing with your customers, like American Airlines, for example, is looking at from a non-secure point of view. That is your sales channel. I mean, it is a critical thing. It is your sales channel to your customers. Your website.
This is not a sales channel. This is just a marketing website. The sales channels are actually secured.
Yeah,
you're right. I get it.
I was asking Dave more of who would we even, is this something you would be involved in? Who do we talk to about this?
Yes, exactly. It's and that's true that this website is just it's not the high priority ones like that. So
yeah, but yeah, these are
in this case.
I agree the point of view. There is nothing wrong in thinking like that to begin with, but it is so trivially simple to convert the entire infrastructure into HTTPS. It doesn't cost you a single penny. Today, this thing is a service available for open source and free, which I'll demonstrate as another exercise. It lets you create HTTPS certificates on the fly. Don't even have to think twice. It automatically gives you a certificate and puts in the right spot. Automatically renews it for you. You don't even have to think twice. Just enable it once. And enabling is easy. And it is open. And here is the documentation. And we have an exercise coming up at some point. It's already written down somewhere on the website. You can go and find it Or
Yeah,
rather,
so remember, bad guys do that too.
sorry.
Bad guys do that too.
Yeah, let's encrypt. You mean let's encrypt is what bad guys do?
They can use security too to their advantage.
Oh yes, correct, and they will. They will. But the idea is what you can do is what you should be doing, as opposed to worrying about what other people can do. Because there will be adversaries all the time, and they just exist everywhere. So what we need to focus on is what we can do, because there's no point in worrying about what they can or cannot or may not or may or do, because that's not in our control. So we control what we do in our domain, in our purview, in our marketing, in our sales, in our operations, whatever we have, and we focus on our thing, and we do our thing the right way as what we think is right for our customers, and let them worry about other people. And yeah, they will exist. Adversaries will exist. They're not going to go away from here. Okay, so enough of this.
Can we take a short break?
Yes, please. Short break. So we'll just start a break timer. And where is that timer? Notification, and disable this do not disturb. Okay, there we go. And the timer is running. Okay, I will come back and continue. Let me get the cable. Where is the cable? Here. started beeping on me. I was late. Sorry about that. Okay, so let's resume what I want to talk about. I'll just check if you're here. Yes, most of you are here. Okay. So, yeah, back to the picture. So in this front end representation of what this image is trying to communicate, I think we discussed it briefly to the extent it allows us to discuss this. But there are two aspects to it, which is this aspect and this aspect, which are separate and not included in this illustration because the picture itself is quite big and they want to put focus on one thing at a time. So the second important aspect, which is about checkout, is the part number 2 of the same picture. And that's what I would like to open next and discuss that from our point of view as to what it takes to enable that complete cycle of checking out a product and actually purchasing it. So that I think is maybe this picture. Yeah, this is it. So this checkout picture actually is available in your Slack chat. And what I'll talk about this is the experience that you get when you go to something like Amazon.com and then you actually purchase something. And so here we go put an item in the cart, and I would like to buy this onion powder, for example, or maybe I think that's the Amazon person delivering something. That was a doorbell ringing and my dog barking. That is what just happened. Apparently, I don't know why he rang the bell. He would have left the item and gone. But if I want to buy this item, so the chili oil from China or something else, I'll put them in the cart, and then this process is actually a separate service, completely different from the first service that you saw, which is what you see when you look at the product catalog and you find the banana or some other thing that you want to buy. Right? That's a completely different checkout experience. It's a different service. That is what you're looking at, that I'm interested in buying this organic banana or organic whatever this thing is, and this chili oil, the 2 items in my cart. Great. How does it translate to the end user? This guy, this end user expects a certain experience in terms of very, very similar to putting an item in a physical cart, taking it out to the location where the person can actually pay for it and then have the item delivered to them. So that's the kind of experience that most of you already know it. So it's nothing new. But the person basically does that thing in the front end portion of the website, which is where the person gets to select a product, puts that in the cart. And when you reach that experience of checking out, that is this piece of puzzle that this picture is trying to communicate to us in terms of what needs to happen and what pieces we need to enable for that particular item in question. Like I have in my shopping cart, I have those items in the e-commerce application, selected them for me. So now what I'm doing is basically interfacing with the checkout application. What this application is going to do is make sure that I give them my money in form of a guarantee or some commitment to pay on a credit card or some other sorts, some other type of payment. And as a consequence, they will create what is called an order with an ID number. And you know this already. I think most of it is trivially simple. But the concept here is you have a bunch of different orders coming in all along the way. And those orders need to be able to put in some form of a workflow. That workflow needs to happen is basically what happens on the back end of Amazon.com, or what happens in the back end of a physical goods and shipment of delivery of a product to your door kind of a setup. E-commerce, basically physical e-commerce. An object reaches your home, an object reaches your office, that kind of a setup. It requires physical workflow. And so that has to be kept track of, and you need to fulfill the order. Only one fill, is it? One L here, apparently. So fulfill the order. You need to do that. And you need to keep track of the order in some kind of a data store. Whatever orders that you see this person has assigned and given, so you can see orders issued in a different location here. You can go to the orders created by this customer. And here are the orders that I have purchased in the past. And the same idea is basically pulled from the data store, this data store, which is keeping track of my customers and orders that I kept in this data store database, which is a RDS representation. And here is a replica of the standby replica of the same database. So these two are basically operating hand in hand. If one goes down, the other one takes over kind of a scenario. But it keeps track of all the orders that I have eventually placed and currently placed for an item that I want to buy, which happens to be this chili oil in my shopping cart right now. So as soon as I put that order, an entry will be created in this database. So it will keep track of that data about the order itself, and also assign a workflow to happen along with it. It will also make sure that I collect my payment. So that order ID will include a payment that is also processed through a third-party service, typically, like the very commonly used service these days, extremely popular, is this service. It's amazingly popular. It might, this is the one I currently use today. So this is the new standard in online payments. It is a service that is available, and you can, basically hook up through an API call to your through your web application or any kind of application. You use the APIs available from here to interface with your checkout applications. As soon as a person gives you a credit card number, you invoke that Stripe as a solution, by the way. And but there are other solutions also available. Stripe is just one of the best ones that I have found, and I like it and I use it. And it costs me 3% per transaction, whatever transaction is, and I'll just pay them 3% and collect the balance. Money goes to my bank account directly. So that's how the Stripe application works. It is integrated into the checkout process. That's how most newer applications are written. Almost exclusively these days, people write on Stripe because it is trivially simple to use it. And it's very developer friendly. That's the reason why people seem to like this very much. And it's a service, meaning it collects.
It also supports a lot of different types of services that like subscriptions and all kinds of things, and it handles all that for you.
Yes. Subscription.
FYI, the Stripe guys, the guys that invented Stripe, actually are ex-PayPal founders.
Okay. So PayPal is also another one, but I don't know why. To me, I don't like it. I think it's a business policy thing that I don't like them. From their policies, I don't like. Functionally, they're good, but this is better. Functionally better, and policies are great, and the timeliness of delivery of money in the bank account is immediate. Like next day, you get cash in the bank. That's so nice. And you have Apple Pay support, Google Pay, Google Checkout support, Amazon Pay support, bunch of other things. Bitcoin payment. It's going to disable Bitcoin apparently for some logistic issues. But Bitcoin is getting disabled from Stripe. But that's a beautiful service. I just love it. No doubt about it. So that's the checkout application. If you are a big company like Amazon, you will build your own Stripe. They have their own Stripe, by the way. Internally, Amazon doesn't need Stripe. Boeing, I don't know if you, I don't know if anybody buys a plane on a checkout shopping cart, but I'm just saying. Maybe there are people from Middle East who will just bring cash and buy a plane. But they may not have a credit card, I guess. So they might just give you a boatload of cash and just get a couple of planes. But
Boeing uses banks
sorry?
to do financing. Boeing uses banks to do financing. Nobody pays in cash. or bring or swipes the credit cards.
I'm just kidding, just kidding. I know, I'm just saying that, people from the Middle East who have oil money can just bring boatload of cash and give you cash up front. That's not how it works, but I'm just joking about it. So imagine Emirates, United Arab Emirates, those guys come in with a tank full of cash, just give you cash and get a couple of planes, maybe buy more than a couple of planes. They can do it. I mean, totally. Not that you would accept cash like that, but possible in theory. Okay, so orders come along. You need to now fulfill the order, and those are what are essentially is a workflow service where you have these worker machines in an auto-scaling fashion, scaling to handle your work. And when the work essentially boils down to a couple of things. For example, first thing you do is you notify the customer, I got your order. So there's an email going out. The second thing you do is you let your warehouse workers, factory workers know that I have this order. So you need to prepare and package and send. That's the second piece of workflow. And the third workflow is delivered, let the delivery notification. The delivery notice has to also go out in some fashion, depending on what the customer wants. So those are the three essential pieces of puzzle in the order delivery fulfillment pipeline. You need to notify the person immediately that I got your order. That's a critical thing. If you don't do that, people get anxious. So therefore, that these workers do is basically interface with an email service that sends out emails to the customer saying, hey, I got your order. So just hold on, I will send it. That's the first thing that these worker machines do in an auto-scaling group is interface with a sending service and send emails. You can see that this experience actually is integrated into, where did I do this? The experience of this email service that I use actually is integrated somewhere. Which website uses that? Let me just go there and find out. No, not EC2. Email service is a separate service somewhere here. Here, simple email service. So separate service available from Amazon, and I will just understand my sending statistics. Very, very low numbers. I have a humongous quota of sending like 1 million emails in every 24 hours, but I send one. So very low send rates because I am not using it actively, but that is the delivery charts. You can see the reputation dashboard and the dedicated IPs that I don't have, and configuration sets and SMTP settings. And I use these settings to send out an email, and I can create a credential. And occasionally I'm starting to use this service to send email notifications of sorts. For example, somebody lost their password, so they get notification. You may have seen those notifications coming to you from the CloudGenius website. Do you see such notifications occasionally pop up that you did something or you forgot your password emails? Those emails come from here. Do you receive such emails at all ever? Occasionally? Yes or no? Anybody? Never?
I think I've changed my password once.
Okay, so there is this thing that seems to send emails, right? Okay, I hope it does. I hope you're receiving those password notification, password forgot, lost password email notifications, because that's what this service will do. Is this worker, one of these guys, will actually interface with the email service and have that email sent out to you saying, hey, here is your link to reset your password. That link is generated on the fly and is sent to you in an email. So in this context of a checkout, the notification needs to go out to the user saying, hey, I got your order. So that's the first thing. The next thing is about the actual decision about, hey, package and send, right? That's the second most important action, which is to actually send. That needs to be sent in a notice to the warehouse worker of some sorts. So these warehouse can be mobile workers, can be robots, depending on how big the application or the company is. But somebody needs to get a notice that you please package and ship. And here is the address you need to send it to. So the address is right there. And so that package and ship action has to be either done by a manual worker or some robot that has to do it. That is a second action. It's a very, very important action from an e-commerce perspective. And so somebody has to receive that notification from the workflow. That's what this workflow service is also handling, is to let the mobile worker or the robot handle the transaction, the physical shipment of goods and services, or whatever you might have. Then comes this third idea, which is here, which is on the front end side. We looked at the e-commerce checkout application portion. And the third idea is the marketing and recommendations engine, which is here. And let's go understand what it does and what it will actually roll out in from a usage perspective. So the idea of generating an experience that produces recommendations is a data science based concept. So if you go here on Amazon's website, it is generating those recommendations on the fly. So, I go buy this, whatever that thing is, Roku, and I get a recommendation about people who buy this also buy that. The recommendation generated on the fly, dynamically given to me. Sometimes I go random things like, exotic items from, say, Sichuan, Chinese Sichuan peppercorns. So I buy Sichuan peppercorns. So I seem to like this, so I buy them. And so I buy this Sichuan red pepper chili powder. Beautiful. So I buy that. And then I get some recommendations. Like people who buy this also get that. And so here you will find that McCormick whole black pepper. That's not really Sichuanese, but whatever. It's a pepper. And so here is another one. Red pepper from Korea. Or more other red peppers. And there is probably a bunch of more recommendations you will see, but they are at least related to the concept of hot pepper. Because I seem to be interested in chili powder. So it seems to be, this guy seems to be interested in hot spices, at least at this point in time. So they are dynamically generating recommendations and they are presented directly here. Like people who buy this also bought that. And so that idea of generation of a recommendation is in data science is known as market basket algorithm. Market basket. You should read that actually. It's an interesting read on its own. Market basket analysis. And so here is a gentle introduction to market basket analysis. So you should maybe read that. Is that the right one? Let's go see. Are they talking sense? Yeah, seems like it. Seems like it. So you read that later on, but that gives you an idea about what a recommendation engine will do when it is trying to recommend you something. So in effect, what they're trying to find out is what is known in statistical science as the confidence level of a similarity. A similarity based on a priori probability. Now, some of these are statistical probability related terms that I am just throwing at you. If you're not familiar with it, don't worry. But just know that read this will help you understand what this thing is about market basket analysis and give you some idea about what's going on under the hood. So that is what this thing is coming from. This customers who bought this also bought that. And you will find most of the times it is fairly accurate and somewhat related to the topic at hand. Occasionally you will find a mistake. For example, no, that is also a chili or some kind of chili. So apparently I'm not able to point a mistake somewhere in the recommendation engine, and most of these results seem to be okay, except not this one. After like 6 or 7 of the 10th page, on the 10th page, I find that this is something that is not directly related to the chili. but it is kind of sort of related to kitchen, cooking, and those categories, but not chili, right? So this item is something else. It is a Detroit style pizza pan, whatever. It has nothing to do with chili whatsoever, but apparently it came up as a recommendation for some reason. And I don't know what that reason would be, but you can find out these things. And you need, when you have like millions of products in your market, in your catalog, you need to run statistical analysis on market basket to understand the similarity and make recommendations. That is a complex and CPU intensive and also time intensive algorithm, by the way. So what does that translate to? Is that you need to do data science, map, reduce. And this MapReduce is an algorithm created by Google guys in 2004 by these guys. What are their names? Ghemawat and Dean. Those two guys created this paper on MapReduce, which is what is the foundation of what you these days know as Hadoop. Is the product that has evolved out of it. So the product that we use, the industry uses left and right, is this product known as Hadoop. It is created based on the work that
Isn't the Google search based on that also?
Yes, correct. Correct.
Originally, Google search was the one that picked it up.
Yes. Yeah, the Google search was constructed based on this concept, and then they eventually came out with this paper later on.
MapReduce, I thought, was done by, or not MapReduce, the other tool was done by Facebook.
Who?
Facebook.
Which one?
The Hadoop.
Cassandra?
I don't know about Cassandra, but when we were using Hadoop, that was associated with Facebook when we started using it.
Maybe it's not Cassandra. Maybe there is something else. But these days, even this Hadoop thing has been not. It doesn't have the favor of the industry anymore. The thing that has taken on is this thing. Let's go pick it up. There, boy. So that thing has taken over. So I kind of sort of taken over on top of Hadoop. So this is the new thing. It is the lightning fast cluster computing. That's the tagline. The thing is known as Spark. It is also an Apache product, and this has taken up quite a bit from adoption, and it works like Hadoop, but also works way faster than Hadoop could. So let's go talk about the speed. It runs programs up to 100 times faster than Hadoop, and it does MapReduce in memory, and 10 times faster it does on the disk. So it is doing it on both memory and disk, but it's basically 100 times faster if you do it on memory, 10 times faster if you do it on the disk, comparing with Hadoop. So it's a successor, if you will, think about it that way. And that's what you look at in this illustration, is this MapReduce concept running. This Elastic MapReduce is a product name by Amazon. That is not necessarily what you need to run. You can run another type of cluster which will do the MapReduce operation for you. Either you use Spark, or you use Hadoop, or you use something else, depending on what your flavor of choice is. But I suggest that you use Spark and not Hadoop. And Spark is open source and available, and you run it on a cluster, and you can run it in Kubernetes, by the way, and there is a module for that. So all these things are available in Kubernetes already. So you basically, this is your Kubernetes cluster running Spark. And in there, you will program it to do market basket analysis. And you are looking at user profiles, you're looking at a ton of e-commerce application logs that are generated based on what people are browsing, what they are visiting, what they are looking, what they are adding to the cart, what they're deferring, what they're marking as their list for future, or save it for my, what's the name for it? Something in there that you will see that Amazon does is if I look at this product and then I will say save for later or something like that. I think that's the button. What's the button is called? I think it's save for later. Yeah, this button called save for later is a way for me to keep track of what I may be interested in the future. If not right now, I can either delete it or save this for later, for example. And maybe I don't want this chili chow, whatever oil, so delete that. So now I have a bunch of items saved for later. So I will eventually buy these things, but not right now. So this is how Amazon is keeping track of my preferences. So those are kept in the application itself. Then random people like me who are visiting this website will eventually click on the onion powder again for some reason. I don't know why, but I seem to be clicking on this powder for some reason. And what Amazon is keeping track of is in our area, in our geography, in our zip code, for example. If there are cases of people like me who are apparently clicking on this organic onion powder over and over and are hovering their mouse on this page for some reason, and some of them add to the cart, some of them actually happen to buy it right away and get it delivered and all that. So Amazon is gathering those things about these events that people are doing, generating about a particular item, like the organic onion powder, for example. And those logs get generated. You will take that logs from the bucket that you will store it in and include it in your analysis as an input. And you will begin to analyze that detail about what people's behavior are from the logs that are coming in, because logs are getting generated. People are visiting your sites, which generates logs, and you need to consume those logs and use Spark-based analysis. An example of that analysis was the market basket analysis of what people are buying and what else they are buying as a consequence. And that is the study that you should, I think, read more before we talk about that, if you're interested, is to understand and identify what is considered as a recommendation. And this generation of recommendation is happening not only by the logs that are coming in from the website, but also from customers' orders and databases. In the database that we know, we have stored our customer orders from the checkout site. That same data store, there is a read replica that you can have allocated to the cluster here running your Spark that will conduct this analysis that is necessary for you to identify recommendations, and you need to do them in almost real time. Almost real-time analysis. That is what is possible today with Spark, is you can actually take that read, the database of customer orders and incoming log files, and appropriately adjust your recommendations that you generate and send that out to the customer through your recommendation service, which basically injects this portion of the recommendation right in the e-commerce site itself. So in the other picture where you see this, the very first picture we saw, which was it this? Yeah, right in this front end, the marketing recommendations are already injected along into the e-commerce application itself, which is what is presented to the end user. And the customer sees the recommendation as soon as they go and search. And it's almost instantaneous as soon as I hit this item. And you see the recommendations coming up. For some reason, I see that people who buy onion also seem to be interested in garlic powder. And so that's what you're looking at. Now, where are these things coming from? Coming basically from the analysis that you just saw. And also, another thing to think about in the same context of marketing recommendations is the idea of this recommendation engine that is suggesting us to include that recommendation right on the page on which the customer is landing, right? This. People who buy this also buy that. Recommendations. In addition to these items showing up on the page where I'm looking at a particular item like the garlic powder, you will also see sometimes Amazon will email out to you saying thank you for buying this item. And when you buy this item, you might also see recommendations right in the email, which is given to you as a receipt or as a order in your inbox. In that email also, you will find such recommendations popping up. And that is what is here, marketing emails being sent out through the email service from the marketing application. And this you can implement either yourself or use an open source product, which I use, which is here. This is the world's largest open source marketing automation project. That's the claim. I mean, it's just a claim, but let's go to GitHub and find out what Mautic actually is and what it does. And so this Mautic is the source code. It has 800 forks, 2,000 stars, and lots of people watch it. 119 contributors, and its stable version currently is 2.12.2. And it was refreshed as late as 7 days ago. So it's a fairly active project. I use this project to send out emails, and I have used it to send it to you. You may have received it. You may have seen those emails. And this is the other side that I've said that I will talk about, which is what I'm opening up right now, and you will see how I use it. It is to help me market. This is my marketing site, by the way. So only I get to see it. You never see it. But I'm showing it to you because I think you need to understand what's going on. So in here, you will see that my customers are globally distributed, as shown in the depth of this color. So most of these people happen to be in the US, and some in Canada, some in Russia, and other parts of the world. But that's where people who visit Cloud Genius website are in these locations. I see some statistics, aggregate statistics that show up to me in form of a report. But more importantly, the primary way I use this is actually let you know that a program is about to start again. So that is my way of marketing, is my way of doing things. Like simply speaking, that's how I do things. So what I do is actually send out to you, and I classify that email to Boeing different from other people. You can see that those two types of emails categorized. And so I'm classifying this, and some of these emails are actually automated. So you will suddenly see an email pop up into your inbox, depending on a context has to trigger. Something has to trigger to make it happen. So something has triggered in the past, and some of you, at least 28.92% of you, have read this email that seems to have been sent to you. Let me just see if I can open it up, and you will probably recognize it. Some of you may have received it, and it looks like this. Did you receive that email?
Yes.
Okay. So this email was sent to you automatically based on certain triggers that happened. The trigger that happened was actually me scheduling this bootcamp. And so it picked up that trigger and automatically sent that email to two kinds of classification I do in my customer base. And I handle Boeing people slightly differently than everybody else. And I think you know that already, because Boeing has this LTP program, whereas other people don't have it. So other people have their other methods, like they pay out of a check or a invoice that I had to create with these companies. Whereas Boeing operates through LTP program. So that message is given to Boeing employees. So that is tuned to you who already have a method of LTP. For other companies, the message is slightly different. So pretty much similar, but I classify and I segregate my customer base, existing customer base who have participated with me, to let them know that the next bootcamp is going to run. That's the only thing that I currently use it for, the automated emails that I send out. So back to this picture, that is my marketing engine, my marketing management app that sends out notifications in form of an email that sends and you receive it because you are the customers who I think may find it interesting. If you don't find it interesting, I also give you a way to unsubscribe. So at the bottom, there is a way to remove yourself from that. If you don't like it, I give you that option to unsubscribe. That's a requirement by law. This is the law that requires us to do this, is to let people have an option to get out of this marketing messaging that I'm doing right now. That law is called CAN-SPAM Act. And that's the law we have to follow. And this is our US government law signed by George W. Bush. And you can read the law, but that's the law that has certain requirements that anytime you send a marketing message, you need to include a bottom footer that says a clear method of unsubscribing. So you should see that unsubscribe button, and you can actually click on that button and the machine will stop sending you any future emails. That's it. No questions, no nothing else. Just click, boom, done. You're removed. And that's how this marketing system works. At least for me, in this example that I use Mautic, but there are various ways to run the same thing. There are various and sometimes nefarious ways of operating the same thing. And one of the big ones in this domain is not open source. It is called Salesforce.com. What is that? Salesforce.com. You may have heard of it. They have a service called Marketing, and the Salesforce Marketing Cloud is a very expensive solution set. I think $3,000 to $4,000 just to start, and that is available, and you can make use of it if you like. I don't know if you use it already or your company uses it already. I don't think you are in that business. At least I'm speaking to Boeing. I don't think you want to use these tools because you don't actually go out and market your planes. But Microsoft uses it. Microsoft has their own solution set. Let's go see what Microsoft does. Microsoft has its own solution. It is called Dynamics CRM. So Microsoft internally uses this for their own purposes, which is to market to people. And that is this application suite of marketing, Dynamics for Marketing preview. And you try the preview. This runs in the Office cloud. And this basically does the same thing like what Mautic does in a much more elaborate aspect. And it is expensive. And you can look at the pricing as to what it means to your cases. So the beginning plans are like $210 per month. My entire cloud bill is $210 per month. So this is just one service, by the way. So it's not right for me, but it's probably right for your companies. Like other companies other than Boeing. Maybe it's a good vehicle for you to consume for your own use. Either you use this solution, or you use this Salesforce solution, or you use another one called Eloqua from Oracle. So this, So Eloqua has been blocked by my Pi-hole because it's a marketing website apparently, and it sends out advertisements. It seems like that's apparently was black-holed, or rather Pi-holed by my machine. So I cannot go there, but I just want you to know that there is this Eloqua service from Oracle. Maybe Oracle Marketing Cloud that might open. So yeah, here it is. Here is the new branding of Eloqua, I think. So Eloqua got acquired by Oracle, and they now have this Marketing Cloud, which is conceptually similar to what we're talking about here. So the concepts here are, identify your customer base, you divide them into segments, and you send them only relevant messages that they opt to receive. They want to receive. If they don't want to receive, let them get out. Very, very simply. We use Salesforce at Boeing. So there we go. So we have an example. So I don't know why you like send out an email, hey, buy one, get one plane for free, something. Just kidding. Sorry
Yeah,
about that.
we're not using it for marketing. We're using it for HR.
Yeah, fair enough. There are tons and tons of applications that Salesforce has. I just give you an example of marketing as just one example. By the way, there are huge sets of solutions for sales and service and marketing, commerce and communities, collaboration, industries, blah, 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 goes on. It's a big company. And same with Oracle. This is just the marketing piece, but then there are other pieces. Go to oracle.com, you will find all of them. Or in the menu, you will find more of them. So products, And here is Eloqua, Oracle Eloqua marketing automation, Oracle Responses, Oracle BlueKai. I don't know what BlueKai is. Data management, content marketing, social marketing, industry solutions.
BlueKai is, it's funny because I used to work with the founder and creator of BlueKai. They do basically what we call behavioral targeting. So whenever you have, like the Amazon stuff, all those things that you checked on, now if you go to your mobile app or you start playing a video game or you start doing other websites, it will retarget you for those onion powder and the peppers, things like that. That's what's behavioral targeting, and that's what BlueKai does.
Yes. It's crazy, and it is at least the industry thinks that it is a way to get the customer's attention, so they do that, track that all the time. And in fact, the next time I will disable that Pi-hole to show you the ideas of how remarketing or Google tag based remarketing works. So Google remarketing, and I think it will not let me open up, but here is the way to, it did open at least. Otherwise I thought I would be Pi-holed again. But remarketing is the Google way of doing what Rob just told you about. And you can do this on your own businesses, large or small, doesn't matter. And what this does is basically tracks people on one platform and then identify them again on other platforms, other devices, other locations, and other properties like Facebook or LinkedIn, and target them and show them the same thing. For example, if I search for that spice, they will show me spice ads wherever I go. And similar thing done by other companies. Facebook Pixel. This pixel that you can take and put on your website. It will track using that one pixel that you inject into your web browser on the back end of your website.
That's exactly what BlueKai does, and Audience Science, the company I used to work for, it's pioneered that concept. So yeah, it was cool.
Yeah. So these are the ways that modern advertising works, but this is not marketing. By the way, just remember these pixels and AdSense, and these are advertising, which is different from marketing. Just want you to understand, when you spend money, that becomes an advertising. When you're not spending money actively and buying other people's attention, it is marketing. My way of describing this thing is the difference between push and pull. If you're trying to push something, that is advertising. If people are pulling it themselves, it is marketing. If people come on their own and want to buy your thing, that is good marketing. If you're trying to push things to the customer, you're basically harassing them in some sense. That is advertising. So that's what people hate. People don't hate marketing. People hate advertising because it comes in the way. And so you put things like Pi-hole in the picture. So you go to Facebook and you don't see ads, and sometimes you do. And so these things people hate. And there is a sponsored fans, whatever, I don't know what this thing is. Some injected feed came along, a suggested post. That is what people don't like, because I don't want to see this Marvel thing, whatever that thing is.
That suggested post is equivalent to the
correct
a retargeting or tracked advertisement.
Exactly. So this is Wakanda. Apparently, I seem to have somewhere liked the movie Wakanda or movie.
That is Black Panther.
Black Panther, yeah.
That's what happened, apparently.
Yeah, because you did all those Black Panther searches and everything, and
so here we go. Yeah, exactly. So it popped up right there in the front page, right? So that's what they're doing, is targeting through Facebook Pixel. So that is the idea here. I want to see my friends' pictures, but apparently they don't want me to see it first. They want me to see this because they want me to buy it, apparently. So if I click this picture for no good reason, I just cost them $10. I just want you to know this. If you are getting harassed by advertisements, you can punish them by clicking on their links for no good reason and closing it. And every time you click, they are paying you they are paying Facebook $10 for no reason for every click. You can punish your advertisers if you don't like them too much. by not buying from them, but clicking on them. The cost is expensive to get on a feed like this. It's really expensive, about $10 to $50 on a per click basis.
Now, Ish,
Yes.
in all fairness, I think that hoodie would look good on you.
I will buy it then. I will buy it. Don't worry. So that might actually be interesting. So I'll buy it the next time. But yeah, the idea that I think you get the idea is to be able to identify, track your visitors, and then don't push. That's the right way to do marketing. If you push, you're doing the wrong way. This is how I think. And it's not black and white. These are very subjective decisions and discussions. But I'm just giving you how I think. Push is bad, pull is good. That's a simple way to think about. And so this is remarketing, and also the idea, one more, which is the last one, is LinkedIn also has a similar thing. LinkedIn also has a pixel. They don't call it pixel though. They call it something else. It's called conversion tracking. So the same idea. You basically set up a tag like this in your browser, in your website, that looks like adding LinkedIn Insight to your website. Come on, open up, and you go inject a piece of code in your campaign manager, which will look like, and I have done this in the past, like in 2014 and 2013, something like that. And so, yeah, I haven't visited this quite a while ago, but I tried this, and you can see that I did back in 2013. Which basically generates a bit of code that you inject on the back end of your servers to let in LinkedIn track your visitors, and then you can place advertisements in the LinkedIn feed. And that is what you're looking at in.
It typically is just a single JavaScript call that has,
yes.
That's very, very tight JavaScript call that calls.
Yes.
And the reason they call it a pixel is it used to be, in the old HTML, it used to be so that it wouldn't show up on the page. It would be an image that was a single pixel that you would put on your page that then had a bunch of query strings after that pixel, and then the system would pull those query strings and log them to the system, and then the database would pick those query string items out, and then that's how it would process and know that it came from your page. But now they do it all in JavaScript, and there is no actual pixel.
Yeah. So in what Rob just said is this kind of a string that you can inject. Let me give you an example of what he's talking about from a specific example. An example string that you will inject would read something like this. Now it has been disabled on my site. As you can see, paused. Google Tag Manager has been paused. This is the code. This is the live code you're looking at. And this is the actual Google Tag Manager tag, which includes this segment. And there is a little Tag Manager tag right there. This tag GTM N5 number, whatever that number is. This is how Google will track visitors to Cloud Genius website and keep track of who's visiting from which location, which time, which browser, what size, what font, what what operating system, what device type, what resolution, and location, geo position, date, time, every single thing that you can keep track of. Keep that data in Google Analytics and use that information to then help me advertise on Google if I want to. That's how they would track this piece of code, Google Tag Manager. And if you go look at that particular tag in the Tag Manager, you will find it has, a highly sophisticated layering in there. I'll show you what I mean by layering. This piece of code that I'm injecting, that I'm not currently using because it has been paused. Let's go see what this actually goes under the hood and does on the Google's website. It is able to interface with a bunch of other services. For example, let's go see Google Tag Manager. I hope it will let me open it. Google Tag Manager. There we go. Sign in, Tag Manager. And here is the tag. And underneath that tag, I have a bunch of services. What services do I have? Latest version. And I have 5 tags. And in there, these 5 tags are the first 2 from Google. The third one is from LinkedIn. The one I just mentioned, LinkedIn Insight. The third one is pixel-based code tracking. It's got custom HTML, which is, I think, Facebook Pixel, but I'm not sure. I haven't gone to this site for quite some time. And Universal Analytics is another Google tracking. Let's go see what it actually does in the LinkedIn Insight. You will find that it tracks using the partner ID 35223, which is the LinkedIn partnership with Google. And they're tracking all pages on which a visitor who is a LinkedIn customer also happens to visit Cloud Genius site will be marked as a LinkedIn visitor. And it will notify LinkedIn that this guy visited this site and also keep track of that in the Google Analytics database. And that's how both Google and LinkedIn will be able to get notifications of a particular web person visiting this site, because I will have this tag in here on the back end of the code, on the back end of the JavaScript in the website, which is currently disabled right there. So it is not active. It will not show you if you go to that site, but the code is there. I can come back here and enable it anytime I feel like. I can just come here and say, you activate.
So
pretty much like this.
Talk about the other side of this.
Yeah, go ahead. Describe that.
So the other side of this, so this is what we call the publisher side. So the publisher adds this pixel, and so what they can do then is every time I come to Cloud Genius's website, he can now create an advertisement campaign on the other side. And when I'm on apple.com or I'm reading my email in Microsoft, I'm going to get his advertising campaign show up in the advertising section, because they know that this pixel, they now are what's called retargeting. They're targeting me for interest, that I've shown interest in his product. And so that's the loop, is the publishers, you can actually pay, he could pay to put this pixel on other people's websites in a co-op, and then he could retarget people on other publishers and other sites for his product. It's a whole ecosystem out there, and there's literally billions of dollars and hundreds of companies doing this.
Yep. And it is a viable thing to do. It is not how I like, so I have disabled it. I tried it, I've disabled it, and it is currently disabled for, I think, quite some time. I haven't actually activated it. Activating takes just 2 clicks, and now it is active. But I will undo that and leave it alone as is, not want to advertise, not doing anything. And this is live code, and I came out of it. The plumbing is there, and I just don't want to use it, so I don't use it. The plumbing I did experiment with the whole thing, like publishing, putting an ad, see what it does. But what I found is, in the business that I am in, it doesn't make sense to advertise, because the moment I advertise, I don't think anybody is going to pop off thousands of dollars on attending a 2-month boot camp. That's not how it works. Nobody would spend that kind of money on seeing an online ad of something and say, oh, this guy looks really awesome. I mean, just go look at him. And I'm going to spend like $10,000 on this guy? Are you kidding me? It doesn't work out like that. It doesn't work. What I have found is advertising does not work. So what makes it work is you talking about it to other people. That's the only way I think it succeeds. There is no other way that I've found that it works. So all I need to do is let you know, and you will talk about it, I hope. And so I hope you need to like the program to be able to have you good things about it in your memory. So when you do these, discuss with your friends, you mention it. That is how the business has been running for so many years, but not because of advertising. Because advertising, if you see this guy, this orange shirt guy, I don't think anybody will pay. Even I would not pay $10,000 just by looking at this guy. No, it doesn't work. So, okay, let's keep forward. How much time we have left? 15
How do
minutes.
we get a refund?
Sorry.
How do we get a refund?
You want a refund? I will give you a refund. I'll process the refund in the original form of payment. How about that?
Okay. Thanks.
Okay. I do offer refund guarantee, by the way. So yes, it's a good question. It's a valid question. And if you don't like the program, you should actually ask for a refund, because that's how it should be. It's good business. That's how it should be. So the only challenge is I'll be refunding you in the original form of payment. So that's how it goes. Okay, let's see what else we can talk about right now. The thing that I really wanted to talk about is the other idea, which is about HTTPS. So that's what I want to talk about. I will cover other charts next time. We have a bunch of charts to discuss and go through to understand how other industries, other businesses actually make use of cloud services. We'll do that sometimes in the next session, which we have in 7th of March. At that time, unless you want to change the agenda, change the topic, you're welcome to. Please remember that you can change the topic on me and tell me to cover something else. I will do that, no problem. But my current thinking is to discuss the other remainder charts and do more exercises, unless you want us to do something different, like go more detail with something else. For example, there is a case that I want to be able to discuss with you about handling high availability storage, Gluster based exercise. We have that exercise handy and functional. We can try that if you like. Or if you like to have discussions like this with other cases, not just e-commerce, we have pictures and I'll paste those links for you. You take a look at that and tell me if you want to go in that direction, and more discussions in terms of how use cases of other industries go along. We take that route. That is the current way that I am thinking of, unless you want to change it. I'm giving you that option. We have 2 more days left, 7 and 9.
Hey, Nilesh,
Yes.
you just remind me, did you see that DigitalOcean came out with a storage offer?
Yes, they do.
Yeah, and it's like initial, like a free, you get free storage and stuff. An email went out.
Mm-hmm.
Thought that was interesting.
Yeah, there's a service available now from Vulture Cloud and DigitalOcean Cloud. They call it, there are 2 different types of storage available. One is called Spaces, and the other one is block storage. Both of them are available now. So here is the Spaces service, which is like S3 bucket, if you will.
Yes.
This is your S3. And in the Droplet side, you will find that there is a service called Volumes service. So that's a storage service, basically giving you an externally attached disk.
Yeah.
So that is
then they've had that for a long time, or what?
So this block service has been there for a long time. This one, I think, must have come out of beta or something.
Yeah, because I got an email, so I wasn't sure if it was like an advertisement or there were. Yeah, it says trial right there by Spaces.
Yeah, 2-month free trial. You are currently using. I am on a trial already. Okay.
I don't know. I just got the email yesterday.
Aha. Okay. That means this thing came out of beta. It was in beta, and I seem to be on a trial, and a subscription for $5 will begin on 13 days. I want to cancel it. I don't want to use it. So I canceled it.
Yeah.
Okay. Great. So I don't have Spaces anymore. Nice. And so that's a new service. So what I'm talking about is not this, but Gluster. That's the exercise I want to be able to let you play with, which is a high-end storage system. If I think a couple of you are interested in storage ideas, so if that's your focus, I will play an Ansible exercise using Gluster if you're interested in that direction. That is functional currently. Or otherwise, we'll go along this route. But for the remainder time we have right now, I think we have like 10 minutes. What I want to show you is an example of HTTPS, how easy it is. And I hope I can run that example in 10 minutes. Let's go see it. Let's go see what we can do. So I'll go to the Cloud Genius site to see a cheat sheet, see if I have a cheat sheet ready. It should be there somewhere. So we'll go HTTPS, not found. How come not found? There it is. No. Where is the exercise? I think this is it. Okay, so this is the exercise we have. Let me go paste a link for you so you can also play along. It's a very easy one to do. And so the link is coming up right there. What this exercise will do is to help us put an SSL certificate in a completely automated way. Now, what this requires is a machine running some application somewhere. So we need to get that. And then install a piece of binary available from this company called Let's Encrypt. This thing called Let's Encrypt is available from the Let's Encrypt website. Okay, come on, where are you? Let's Encrypt. No, copy, open, Let's Encrypt. That website has this getting started documentation. You will follow along and you can go that route, or you can go in easier route. Even easier than that is this exercise, which is what I'm going to describe to you, is this concept, which is you need to have some kind of a machine running some service, running something here. And it is currently HTTP. You need to have a name of some sorts, domain name, and that name has to match this IP address. If that matches, and then if you go to this Let's Encrypt website as a service that we run a service for, it's an open service, and you run this Let's Encrypt binary right here. And what happens as a consequence is it will present a challenge to the service. The service will come back and validate you, but it doesn't know where to go. So it goes to your site by the domain name you have chosen. And if the domain name correctly points to the IP address you have at hand, then it issues you a certificate. And then you can use that certificate right here. And then once you have that certificate, your site becomes HTTPS. As simple as that. That's how we will see it happen in an example that I'm going to build right now. And so the idea is we will first thing get a machine and then install Docker and run a bunch of things in there. That's what I'm going to do right now. So we will, first thing is get a machine. So here we go to DigitalOcean as an example, get a machine from them. So we'll say DigitalOcean, please give us a machine. And we have 5 minutes left. Oh man. Let's see if we can speed up. So let me log in. Where is the login button? Login. And then I am already logged in. So I grab a machine there and I'll say, give me some machine somewhere. So this is the machine I get. And I need to put a SSH key in there. So I grab this machine and I say, give it to me in San Francisco and put my new key. My new key pair is this key pair I would like to paste. So I grab my key pair. I cat my idrsa.pub and pipe it to copy buffer and then paste it here. And I say, this is my id_rsa dot whatever, that's the name, add. The key is already on my account. What? How come? How come the key is already on my account? Are you sure it is their account? No, I'm on the wrong.
There is another key in DigitalOcean that probably matches.
This one.
New SSH key on the left or Nilesh, either or.
Yeah, this Nilesh I think matches for some reason. So that's a good thing if it matches, nice. But I like to cross check because I'll be surprised if it actually matches because that's not what I expect. But maybe I did see the news. That's a good thing. Okay, I'm using the key and I create the machine. This machine gets ready and I'll connect to it. So that's what I'm waiting for. The machine gets ready and I get the IP address and I connect to the machine right here. And I'll say terminal, please. And in there, I will say SSH, and then root at that IP address. I'm waiting for it to show up. and I will configure that machine to run Docker and then run some application and get an SSL certificate loaded up. So copy that thing, connect to it.
I'm surprised, Nilesh, that this isn't a Terraform file.
Surprised what is not in Terraform file?
This whole setup. We just got done doing Terraform. It should have been a Terraform file.
I know, but then you don't
I'm
describe the concept, right? You have to understand the concept.
I know. I'm joking.
I know. I have. If you're so much into Terraform, let me give you an exercise. I'll give you an exercise, by the way. The exercise will be to extend Terraform hard way. The hard way project that we did. This one, you do this thing through Terraform. So I give you some starting point. Terraform hard way. So this exercise has done some of the work already, by the way. This guy has done it, but he did it like a year old ago. So it's about 2016, roughly about more than a year ago. He did something that is useful. So grab that and extend it to make it current. That's the exercise. If you're into Terraform, so extend this to match the current state of the hard way of doing things. That's the exercise. You can do it if you like. It's a good challenge. Okay, let's move. What I want to do is in here in this machine, I want to set up Docker. So we'll go set up Docker right there. So it becomes a Docker machine in a few. Once that machine becomes a Docker machine, I'll start a reverse proxy and also set up a companion to handle the Let's Encrypt certificate generation and automation part. So that currently is setting up with Docker. And then once it finishes up, I will then set up the reverse proxy, which you already know what it is. And but from a picture perspective, what I'm really doing is I'm grabbing a machine, making it Docker. In that machine, I'll be putting a reverse proxy and then a companion for Let's Encrypt. This companion application will run in a container. This reverse proxy also runs in a container. Then I'll actually put some application in another container. So three things. This reverse proxy proxies. This looks at the reverse proxy and interfaces with Let's Encrypt, the external service. And this is running on port number 80. This is running on 443. And this generates certificates for you. So it uses the HTTPS certs. And these certs will be used by the reverse proxy and render everything outside in HTTPS. And so the user who visits this box will need to visit this box by a name, not the IP address. So this IP address that I have here, this address that address that I logged into, I need to make sure that it currently runs my reverse proxy. So I'm running this reverse proxy right there. And then also running the companion, which is the next step. And in the meanwhile, I'll open my Cloudflare account and set up an A record for this setup that I have here in the Cloud Genius domain and the DNS servers. And I will create a new DNS entry. In the DNS section, I'll say, get it some domain name like some other domain. And so I'll create that domain, some other.cloudgenie.us, and give it an IP address that I have for that machine, which is available to me from DigitalOcean. So I copy that IP address and go here and say, this is your IP address. And so please set a new record for some other domain, subdomain, and add it. So now my website should be some other dot, whatever that name. And so that is what we just did. We finished our reverse proxy set correctly and running. You can see it running right now. I will now set up a companion container to look at the proxy and actually generate certificates. That's this companion running. And then we start some application. So the application itself goes like this. So the third thing that I'm running is an application that will basically this application itself. I first ran reverse proxy, second I ran a companion container, and third an application. This is the third one I'm going to run, and all three of them in the Docker containers. And this is the application running now. So those three are running. And when you see that this loads up, it will automatically be HTTPS enabled because I chosen that name, some other, and it already points to the correct IP address. So as soon as this thing runs, you will find that it is already enabled for HTTPS. So let's go visit that site, and you will see that the HTTPS is already active. I'll go to some other right now. You will find that nothing is working because the Nginx setup is functional, the reverse proxy is responding, but the actual application is not in the background. Right now, it just finished. So Docker ps-a should show us the application, the companion container to generate certificates, and the reverse proxy. Three of them are running. Now, if I refresh the page, I see this site. If I visit the HTTPS site, it will not yet give me because the certificate is currently getting generated. If I visit and say dig some other .cloudgenie.us, do I actually reach the same address? Apparently so. So if I SSH to that location, what do I see? I see the same IP address, and that tells me that the site should be generating our certificates right now. So we'll see Docker logs for the companion. So let's go first of all, check the processes and find the logs for this container, which is the companion container, which will give us whether the certificate generation actually completed or not. So Docker logs, and that should show us generating new certificate, retrieving let's encrypt terms and service, creating an account key, saving account key JSON. And so that thing is now HTTPS already. It just finished. So now let us go grab this site URL and curl it. So go curl-i, and it shows you that it is currently HTTPS successful. So let's go open up a browser. And in that browser, we'll open up this site. Firefox browser, please open some other site, and there it is, HTTPS correctly functioning. Click and view the information about the certificate itself. You see that this certificate was issued by Let's Encrypt. It will expire in 3 months. The certificate itself shows that it was issued like just now on March 5th to this site called someother.cloudgenie.us by this authority. And that's the quick exercise. Now it is a very, very quick one, but you saw that it worked end to end without any issues. And one thing you note that this expires on June 3rd. Today is March 5th. So in a matter of 3 months, the certificate will expire. Ouch. Is there an ouch? Not really. Not really. It is not an ouch because we have automation. This thing is running a companion container right here. And it is going to keep track of that automation. This automation companion will keep track of certificates about to expire in the next month or so. And it will automatically renew certificates and get new ones every so often. So typically a certificate issued by Let's Encrypt is valid for 90 days, but this application container running the companion container will automatically renew after 60 days of issuance. Or in other words, 30 days before expiration, it will automatically go ahead and renew the certificate for next 90 days. That's how the system works. And it is trivially dead simple. And with that, I will pause recording.